Before we begin, take a moment to let the day fall away. There is nowhere else you need to be right now. No one you need to answer, nothing you need to solve. Just this quiet room, this soft darkness, and the sound of a voice drifting alongside you like a slow current on still water. If you haven't already, let your body settle into whatever feels most comfortable. Let the pillow take the full weight of your head. Let your shoulders drop away from your ears. Let your hands rest wherever they naturally want to go, loose and still. If it feels right, you can let your eyes close now. You don't need them for what comes next. We are not looking at anything sharp or bright tonight. We are going to spend some time with something very far away, something soft and old and ringed with light, and the only thing asked of you is to lie here and listen, drifting at the very edge of sleep. There is a point of light in the night sky. You may have seen it without ever knowing its name. It doesn't twinkle the way stars do. It shines with a steady, warm, pale gold glow, almost like a small lamp left on in a distant window. If you were to look at it with just your eyes, on a clear night far from city lights, you might mistake it for a bright star, one of the ones that don't flicker much. But it isn't a star, it's a planet, a world, and it has been watched by human eyes for longer than we have written records to tell us what those early watchers thought. Long before telescopes, long before cameras, long before anyone knew what a planet really was, people looked up and saw that same steady light and gave it names, told stories about it, folded it into their understanding of the sky. Tonight we are going to spend some time with that light. We are going to drift toward it slowly, the way you might drift toward a distant shore on a very calm sea. No hurry, no urgency, just a slow, easy journey outward into the dark, toward a soft ringed light called Saturn. Saturn is one of the brightest things in the night sky, but its brightness is not harsh. It's more like the glow of honey held up to sunlight, muted and warm. Even when you know exactly where to look, it doesn't demand attention. It just waits there, patient and still, as it has waited for every generation of humans who ever tilted their heads up and wondered. The name Saturn comes from the Romans, who named the planet after their god of time and agriculture, a quiet and slow-moving figure associated with the turning of seasons and the long, steady passage of years. There is something fitting in that, because everything about Saturn feels unhurried. Its light reaches us after traveling through space for a long, long time. The planet itself moves through its orbit at a pace that makes our own year feel brief and quick by comparison. It is a world for the patient, a world for the still, a world for a night like this one, when sleep is taking its time and there is no reason to rush it along. Let's begin the journey from right where you are. You are lying somewhere comfortable, in a room that is probably dark or nearly dark, and outside that room, beyond the walls and the roof and the thin blanket of atmosphere that wraps around our planet, space stretches out in every direction. It's easy to think of space as empty, a vast nothing between the planets and the stars, but that's not quite right. It's more like a very deep, very quiet ocean, and scattered across it are islands of light. Our Earth is one of those islands. Saturn is another. And between them lies a distance so large that the numbers start to lose their meaning if you hold them too tightly. So we won't hold them tightly. We'll just let them drift past, like mile markers on a road you're traveling in the dark, barely visible from the corner of your eye. The distance from Earth to Saturn changes all the time, because both planets are moving in their great slow arcs around the Sun. Sometimes Earth and Saturn are on the same side of the Sun, relatively close to each other in the vast scale of the solar system. At those times, the distance between them is about 1.2 billion kilometers. At other times, when they're on opposite sides of the Sun, the distance stretches to about 1.7 billion kilometers. These are numbers that are hard to feel in the body, so let's find another way to understand them. Think of it like this. If you could drive a car straight up into the sky at highway speed, without stopping for anything, it would take you something like 1,700 years to reach Saturn. That's longer than the time between the fall of the Roman Empire and now, longer than the great cathedrals of Europe have stood, longer than most things we can name. The light from Saturn, on the other hand, makes the same journey in about 80 minutes. Light travels fast, but even light takes its time across these distances. When you look at Saturn in the night sky, you are seeing light that left the planet more than an hour before it reached your eyes. You are seeing into the past, just a little, not a deep past, not the ancient past of distant galaxies, but a gentle, recent past. The light that touches your eye left Saturn while you were still settling into bed, or maybe while you were brushing your teeth, or maybe while you were just starting to think about turning in for the night. It has been traveling all that time, crossing the silent space between worlds, just to arrive here, now, as a soft point of gold in the dark. Saturn is visible to the naked eye. You don't need any special equipment to see it. On a clear night, if you know where to look, you can step outside and find it with just your own vision. It won't show you its rings without a telescope. It won't reveal the faint bands of cloud that wrap around it, or the moons that trail alongside it like quiet companions. But it will be there, a steady, warm presence among the stars, and that alone is something worth pausing on. For most of human history, that was all anyone knew of Saturn, a point of light, a wanderer among the fixed stars, moving slowly along its path, year after year, generation after generation. The ancient Greeks called it Chronos, after their own god of time. The Babylonians tracked its movements and recorded them in clay tablets. People in China, in India, in the cultures of the Americas, all noticed this same light and gave it a place in their understanding of the heavens. For thousands of years, Saturn was nothing more than that distant glow, and it was enough. It was a marker of time, a keeper of seasons, a quiet companion in the night. Now we know more, of course. We have sent spacecraft across that enormous distance, and they have returned images and measurements and sounds. We know about the rings, the moons, the storms, the strange hexagon at the North Pole. We know Saturn is a giant ball of gas, with no solid surface to stand on. We know its winds are among the fastest in the solar system. We know its largest moon has lakes of liquid methane and a thick orange atmosphere. All of that knowledge is real, and we will spend time with it in the sections ahead. But tonight, at the very start of our journey, I want to leave all that information waiting gently in the distance. Before we get to the rings, before we get to the moons, before we get to the great storms and the speeding winds, I just want you to sit with the simplest version of Saturn, the version that humans have known for most of our time on this planet. A soft, ringed light in the night sky, a distant world, waiting patiently in the dark. Nothing more is needed right now. Let's take a slow breath together, not a deep breath that requires effort, just a natural, easy breath, the kind your body takes when you're not paying attention to it at all. Breathe in gently, and as you breathe in, imagine the distance between yourself and that distant point of light. Not as a number, not as a measurement, but as a kind of spaciousness, a wide open calm that stretches between here and there. And as you breathe out, let yourself sink a little deeper into the surface beneath you. Let the bed or the couch or the floor hold you up, fully, without you needing to do any of the work. You don't need to hold yourself in place. You don't need to keep track of time. You don't need to do anything except lie here and breathe and listen as we begin our long, slow drift toward Saturn. The journey we are taking tonight is not a journey of the body. You will stay right where you are, warm and still. It's a journey of attention, a slow turning of the mind's eye outward, away from the small concerns of the day, away from the to-do lists and the half-finished thoughts, and the little loops of worry that so often keep us company in the dark. All of that can wait. It will still be there in the morning if you need it, though you may find you don't need it as much as you thought. For now, let it all recede. Let the room become a little softer around the edges. Let the feeling of your own body become a little less distinct, as if you were slowly dissolving into the quiet, the way a single drop of water dissolves into a still pond. There is nothing alarming about that feeling. It's just relaxation, the slow unwinding of tension you've been carrying without even noticing. Let it happen. Let the unwinding continue. Saturn is a good companion for a night like this. It doesn't rush, it doesn't demand. It just circles the sun in its own slow time, taking nearly 30 of our years to complete a single orbit. Think about that for a moment. A year on Saturn lasts almost 3 decades of Earth time. The last time Saturn was in the same place in its orbit as it is tonight, the world was a very different place. You were a different person. The things that worry you now probably didn't exist yet, or existed in forms you couldn't have predicted. Saturn doesn't care about any of that. It just keeps moving, steady and slow, tracing the same path it has traced for billions of years, holding its rings and its moons in their quiet gravitational dance, utterly indifferent to the small dramas playing out on our little blue world. There is something deeply restful about that indifference. Saturn is not judging you. It is not waiting for you to do anything. It is not keeping score. It is just there, a soft light in the dark, doing what it has always done, and you are just here, a soft body in the dark, doing what your body knows how to do. Resting, breathing, letting go. As we drift forward into the sections ahead, we will move closer to Saturn in our imaginations. We will pass through its rings and meet its moons, and learn the names that astronomers have given to its various parts. But we will do all of that slowly. There is no rush. The facts will be there when we arrive. They don't need to be crammed into your mind. They can just drift in, the way light drifts into a room at dawn, so gradually that you don't notice it happening until it's already done. That's the pace we're keeping tonight. The pace of slow revelation, the pace of a world that takes 30 years to circle the sun, the pace of light crossing 1 billion kilometers of empty space just to reach your closed eyes. So let yourself be still. Let the dark hold you. Somewhere out there, beyond the walls of this room, beyond the thin shell of the atmosphere, beyond the moon and the familiar inner planets, Saturn is shining. It has been shining for more than 4 billion years, and it will be shining long after we are gone. That thought might sound sad, but it doesn't have to be. It can be peaceful. It can be a reminder that the things that trouble us are small, in the grand scale of things, and that smallness is not an insult. It's a relief. You are small. I am small. Everything we worry about is small. And that's okay. That's more than okay. That's the very thing that allows us to rest. The universe is vast and calm and largely indifferent, and somewhere in that vastness, a ringed planet glows softly in the dark, and it will still be glowing when the sun rises tomorrow, even if you can't see it in the daylight. It's always there, it's always moving, and tonight it is moving with you, as you drift slowly towards sleep. Take another breath now, as soft and easy as the last one. Feel the air move into your lungs without any effort at all. Feel the weight of your body pressing down into the surface below you, heavy and warm and safe. The room is quiet, the night is still, and somewhere out in the deep dark, a pale gold light is waiting for us. We'll drift toward it together, one slow step at a time, in the sections that follow. For now, just rest. Just breathe. Just let the sound of these words carry you a little further from the shore of waking, out into the calm water where sleep is waiting. The journey has already begun, and there is nothing you need to do except let it carry you along. The journey has already begun, and we are drifting now, slowly, through the quiet dark, toward a light that has been shining for longer than human beings have walked the earth. That pale gold point in the night sky has a long history, not just in the physical sense of how it formed billions of years ago, but in the stories people have told about it, the names they have given it, the way they have looked up and wondered. Before we get to what Saturn is made of, before we talk about its rings or its moons or its strange weather, let's spend some time with the people who first watched this light and tried to understand it. Because long before anyone knew Saturn was a planet, long before anyone knew it had rings or knew it was made mostly of gas, it was simply a point of light that moved differently from the stars, and that difference was enough to catch the human eye and hold it. For most of human history, the night sky was a familiar companion. Without electric lights, without cities glowing bright all night long, the stars were visible almost everywhere, on almost every clear night. People knew the patterns. They knew which stars rose at what time of year. They knew the slow parade of constellations as the seasons turned. And among all those fixed points of light, there were 5 that didn't stay put, 5 lights that wandered slowly across the background of stars, moving from constellation to constellation, looping and pausing, and sometimes even reversing direction for a while, before continuing on their way. The ancient Greeks called them planetes, which means wanderers. From that word we get our modern word planet. And Saturn was one of those 5 wanderers, visible to anyone with clear skies and a reason to look up. The 5 wandering lights were Mercury, Venus, Mars, Jupiter, and Saturn. Every ancient culture that left written records of the sky noticed them. The Babylonians tracked their movements with careful precision, recording their positions on clay tablets more than 3,000 years ago. They used these movements to mark time, to plan festivals, to make decisions about when to plant and when to harvest. The movements of the planets were part of the order of the world, a great slow clock in the sky that anyone could learn to read if they were patient enough. Saturn, with its slow, deliberate pace, was associated with time itself in many of these early cultures. It moved more slowly than the other wanderers. It took longer to complete its circuit of the sky. It seemed, to those watching, like an old and patient god taking his time across the heavens. The name we use for this planet today comes from the Romans. They called it Saturnus, after their god of time and agriculture. Saturn was a figure from the deep past in Roman myth, a god who ruled during a golden age when life was simple and peaceful. He was often shown as an older man carrying a sickle, a tool for harvesting grain. The sickle connected him to the turning of the seasons, the slow rhythm of planting and growing and reaping that governed so much of ancient life. There is a quiet poetry in this name, a planet that takes nearly 30 years to circle the sun, named for a god of time and harvest. A planet that seems to embody slowness, patience, the long view. Even before anyone knew what Saturn really was, the name fit. But knowing that a light moves in the sky is not the same as knowing what that light is. For thousands of years, no one knew. The wanderers were assumed to be some kind of celestial being, or perhaps lights attached to invisible spheres that turned around the earth. The idea that they might be worlds, places you could visit, was not something most people considered. They were simply there, part of the sky, part of the great order of things. And then, in the early 1600s, something changed. An Italian astronomer named Galileo Galilei built a telescope and pointed it at the night sky. He was not the first person to build a telescope, but he was among the first to use it for careful, systematic observation of the heavens. He looked at the moon and saw mountains and craters. He looked at Jupiter and saw 4 small points of light circling around it. And in the year 1610, he looked at Saturn. What he saw confused him. Saturn did not look like a single round point of light, the way other planets did. It looked like a planet with something attached to it, something on either side. Galileo described what he saw as ears, or sometimes handles, or sometimes he compared the planet to a head, with 2 smaller bodies pressed against its sides. He didn't know what he was looking at. The telescope he used was not powerful enough to show the rings clearly. The image was blurry and small, and the rings, seen edge-on or nearly so, looked like 2 lumps attached to the planet. Galileo was puzzled. He drew sketches of what he saw, showing a central circle with 2 smaller circles on either side, and he wrote about the mystery in his notes, using coded language to protect his discovery until he could study it more. Then something even stranger happened. A few years later, Galileo looked at Saturn again, and the handles were gone. The planet looked like a simple round ball, just like any other planet. He was baffled. He wrote that he wondered if Saturn had devoured its own children, a reference to the myth of the god Saturn eating his offspring. In truth, what had happened was that the rings had shifted their orientation relative to Earth. Saturn's rings are very thin, and when they are seen edge-on, they can seem to disappear entirely, even through a telescope. Galileo had no way of knowing this. He had discovered something remarkable, but he didn't have the tools or the framework to understand what it was. He died without ever knowing that Saturn had rings. The mystery stayed unsolved for several decades. Other astronomers looked at Saturn with their own telescopes, and they too saw strange shapes, glimpses of something that wasn't quite right. Some saw a single ring, some saw two, some saw nothing at all. The telescopes of the time were still quite crude by modern standards, and the images they produced were small and dim. It took a patient and methodical mind to piece together what was really going on. That mind belonged to a Dutch astronomer named Christian Huygens. Huygens was born in the Netherlands in 1629, and he grew up to become one of the most important scientists of his era. He was interested in many things, including the design of better telescopes. He and his brother built their own lenses, grinding and polishing the glass by hand, and they produced telescopes that were sharper and more powerful than most of what was available at the time. In the year 1655, Huygens pointed his improved telescope at Saturn. He studied the planet carefully, night after night, watching the strange shapes that appeared and disappeared and changed. And gradually, over months and years of patient observation, he came to a conclusion that no one had reached before. Saturn, he realized, was surrounded by a ring, a thin, flat ring that circled the planet but didn't touch it. This ring explained everything that had puzzled earlier observers. When the ring was tilted toward Earth, it appeared as a broad band of light. When it was edge-on, it disappeared. The handles Galileo saw were just the parts of the ring that extended beyond the planet's disk on either side. Huygens published his discovery in a book called Systema Saturnum, which came out in 1659. In that book, he also announced the discovery of a moon circling Saturn, a moon we now call Titan. It's hard to overstate what a leap this was. Before Huygens, no one in human history had imagined that a planet could have a ring around it. There was nothing like it in the sky. The moon had craters, Jupiter had moons of its own, the sun had spots. All of these were surprising, but they were variations on a theme, round bodies on round bodies. A ring was something else entirely. A ring was a new category of thing, and Huygens figured it out not by traveling to Saturn, not by building a bigger telescope than anyone else, but by watching patiently, thinking carefully, and letting the evidence lead him where it wanted to go. Even after Huygens, much remained unknown. The ring was visible, but what was it made of? Was it solid, like a thin sheet of some unknown material? Was it liquid? Was it a cloud of tiny particles? These questions would take centuries to answer. In fact, some of them are still not fully answered today, and we will sit with those unanswered questions later in our journey. For now, it's enough to know that the ring was seen and named and slowly accepted as a real feature of the planet, a strange and beautiful thing that set Saturn apart from all the other wanderers. Over the centuries that followed, more details came into view. Better telescopes revealed that the ring was not a single band but several, with gaps between them. The largest and most famous gap was seen by an Italian-born astronomer named Giovanni Domenico Cassini, working in France in the late 1600s. He saw that the ring was divided into two main parts by a dark line, a gap that is still called the Cassini division in his honor. Cassini also discovered several more moons around Saturn, adding to the growing picture of a complex little system orbiting the planet. Each new generation of telescopes brought a little more clarity, a few more moons, a better sense of the structure of the rings. But still, no one knew what the rings were made of. No one knew what the planet itself was like beneath its cloud tops. No one knew if Saturn had a surface, or what kind of atmosphere surrounded it. Those answers would have to wait for the age of spacecraft, still centuries in the future. So for most of human history, Saturn was a mystery wrapped in a gentle glow. It was a light in the sky that moved in ways that didn't quite fit the patterns of the stars. Then it was a planet with strange handles that came and went. Then it was a planet with a ring, and then rings, and then moons, and then more moons. Each step in understanding took time. Decades passed between major discoveries. The pace was slow. There was no rush. The planet was not going anywhere. It would still be there, circling the sun in its leisurely way, waiting for the next patient observer to look up and notice something new. And that is where we will leave things for now, suspended in the long, quiet centuries before the first photographs, before the first space probes, before the flood of data that would eventually come. The ancient sky watchers saw a wanderer and gave it the name of a god. Galileo saw handles and didn't know what they were. Huygens saw a ring and understood. Cassini saw a gap and a handful of moons. Each of them, in their own time, added a small piece to the picture. A picture that is still not complete, a picture that may never be complete, and that's all right. The not knowing is not a failure. It's an invitation. It's a reason to keep looking, to keep wondering, to keep drifting slowly through the dark. The pale gold light is still there, just where it has always been. It has watched over every human generation that has ever lived. It has seen empires rise and fall. It has seen languages born and forgotten. It has seen our ancestors look up from their fires and their fields and their rooftops, wondering what that steady light might be. And now, tonight, it sees you, lying here in the dark, breathing slowly, letting the day slip away. You are part of that same long chain of watchers. The same light that touched the eyes of ancient Babylonian astronomers is touching your eyes now, or would if you were outside looking up. The same mystery that puzzled Galileo is the mystery we carry with us as we drift forward into the next part of our journey. Take a slow breath. Feel the weight of all those centuries, all those watchers, all those quiet nights of observation and wonder. They are behind us now, but their questions are still alive, and we will carry those questions with us as we move closer to Saturn, as we begin to learn what the planet is, where it sits in the great order of the solar system, and what it would be like to see it up close. But all of that is for later. For now, just rest in the knowledge that you are looking at something ancient, something that has been watched for as long as there have been eyes to watch, something that still holds mysteries it has not yet given up. The journey continues, slow and easy, out into the quiet dark. The journey continues, slow and easy, out into the quiet dark. And now, having spent some time with the people who first watched Saturn from afar, we can begin to move closer. Not physically, of course. You are still right where you have been, warm and still, breathing softly in the dark. But in the mind's eye, we can drift outward through the solar system, past the familiar inner planets, past the asteroid belt with its scattered rocks, out to where the sun's light grows dimmer and the distances grow wider. This is the realm of the giant planets, and Saturn waits for us there, circling the sun in a long, patient loop that takes nearly 30 years to complete. To understand Saturn, it helps to understand where it sits in the great order of things. Our solar system is arranged like a series of concentric circles, with the sun at the center. Closest to the sun is Mercury, a small, rocky world that bakes in the intense heat. Then comes Venus, wrapped in thick clouds. Then Earth, our own blue and green home. Then Mars, a cold red desert. These four are the inner planets, all of them made mostly of rock and metal, all of them with solid surfaces you could stand on, if you had the right suit and the right protection. They orbit relatively close to the sun and to each other, and their years are short by the standards of the outer solar system. Beyond Mars, there is a gap, and then a broad ring of rocky debris called the asteroid belt. It's not a dense field of tumbling boulders, the way movies sometimes show it. The asteroids are spread very thin across an enormous volume of space. If you were standing on one asteroid, you probably wouldn't be able to see another one with your naked eye. They are small and far apart, the leftover building blocks of a planet that never quite formed. Beyond the asteroid belt, everything changes. The planets grow larger, the distances between them stretch out. The sun becomes a smaller, more distant point of light, and the planets themselves are no longer made of rock. They are made mostly of gas and ice, enormous spheres of hydrogen and helium and other light materials, with no solid surface to stand on. These are the giant planets, and there are 4 of them. Jupiter first, the largest. then Saturn, then Uranus, then Neptune, out at the far edge of the known planetary system. Saturn is the sixth planet from the Sun. If you count outward from the center, it goes Mercury, Venus, Earth, Mars, Jupiter, and then Saturn. It sits in the middle of the giant planet zone, not as large as Jupiter but much larger than Uranus and Neptune. Its orbit is vast by the standards of the inner planets. The average distance from the Sun to Saturn is about 1.4 billion kilometers. Let that number sit for a moment. 1.4 billion kilometers. It's the kind of number that is hard to feel in the body, hard to picture. We can try to make it more real by comparing it to something we know. The distance from the Earth to the Sun is about 150 million kilometers. That's already a huge distance, a distance so large that it takes sunlight about 8 minutes to cross it. When you look at the Sun in the sky, you are seeing light that left the Sun 8 minutes ago. Saturn is nearly 10 times farther from the Sun than Earth is. 10 times the distance. 10 times the travel time for light. Sunlight takes about 80 minutes to reach Saturn. That's an hour and 20 minutes. When the Sun rises on Saturn, the light that touches the cloud tops began its journey more than an hour earlier. By the time that light arrives, it has spread out across nearly 10 times the distance, which means it is much dimmer than the sunlight we experience here on Earth. From Saturn, the Sun would look like a bright point of light, much smaller than the disk we see in our sky, but still far brighter than any star. It would cast shadows, but those shadows would be softer, the light less intense. The warmth from the Sun would be much weaker too. Saturn is a cold place, far from the central fire that drives so much of the activity on the inner planets. The distance from Saturn to Earth changes as both planets move in their orbits. At their closest approach, when Earth and Saturn are on the same side of the Sun, the distance between them is about 1.2 billion kilometers. At their farthest, when they are on opposite sides, it stretches to about 1.7 billion kilometers. These numbers can start to feel abstract, so let's find another way to hold them. Think of it like this. If you could somehow drive a car straight up into the sky at highway speed, without stopping, without slowing down, it would take you more than 1,500 years to reach Saturn. That's longer than the time between the fall of Rome and the present day. That's longer than most human institutions have existed. That's a span of time that contains entire eras of history, entire movements of peoples and cultures and languages. And yet, in the scale of the solar system, Saturn is still one of our closer neighbors. It is not the most distant planet. It is not even close to the edge of the Sun's influence. It sits in the middle distance, a kind of gateway between the inner solar system we know and the outer darkness where the ice giants orbit and the Kuiper belt stretches out into the deep. Because Saturn's orbit is so large, it takes a very long time to complete one full circuit around the Sun. A year on Saturn lasts about 29.5 Earth years. Think about that for a moment. 29.5 years. If you are 30 years old, Saturn has made just one full orbit since you were born. If you are 60, Saturn has circled the Sun twice in your lifetime. All the things that have happened in those years, all the changes in your life, all the seasons that have come and gone, and Saturn has been moving through just a fraction of its own slow year. It was in roughly the same part of its orbit when you were born as it was when you turned 29. It will be in roughly the same part when you turn 59, and again when you turn 88. There is a steadiness to this, a kind of deep patience that has nothing to do with human timescales. Saturn does not measure time in days or weeks or months. It measures time in decades and centuries and millennia. It has been circling the Sun in this same slow rhythm for more than 4 billion years, and it will continue for billions more, long after we are gone, long after everything we have built has crumbled to dust. The slowness of Saturn's year is not a flaw, it's not a delay, it's just a different way of marking time. On Earth, we are used to quick cycles. A day lasts 24 hours, a month is roughly 30 days, a year brings 4 seasons, each one lasting about 3 months. Everything feels fast, urgent, pressing. Saturn doesn't know that urgency. Saturn's seasons last about 7 Earth years each. If you were born on Saturn in winter, you would be 7 years old before spring arrived. You would be 14 before summer began. You would be 21 before autumn came. A full cycle of seasons would take your entire childhood and young adulthood. There is something deeply restful about imagining that pace. A world where change comes slowly, where the seasons stretch out across years instead of months, where there is no rush because rushing wouldn't accomplish anything anyway. Saturn just moves at its own pace, and the sun waits, and the orbit unspools in its own time. The orbit itself is not quite a perfect circle. Like all the planets, Saturn moves in an ellipse, a slightly flattened circle with the sun at one focus. The difference between its closest approach to the sun and its farthest point is not huge, but it is measurable. At its closest, Saturn is about 1.35 billion kilometers from the sun. At its farthest, about 1.51 billion kilometers. This means that the amount of sunlight Saturn receives changes a little over the course of its year, but not by a dramatic amount. The seasons on Saturn are caused more by the tilt of the planet's axis than by the changing distance to the sun. Saturn's axis is tilted at about 27 degrees, which is similar to Earth's tilt of about 23.5 degrees. This tilt means that as Saturn moves through its long orbit, first one pole is angled toward the sun, and then the other. The northern hemisphere gets a long, slow summer, while the southern hemisphere experiences a long, slow winter. Then they switch, and each of these seasons lasts about 7 Earth years. Imagine a winter that lasts 7 years. Imagine the slow dimming of light at one pole, the gradual cooling, the quiet settling of the atmosphere as the sun sinks toward the horizon and then stays there, just out of sight, for year after year after year. And then, just as slowly, the sun begins to climb again. The light returns by degrees. The atmosphere warms. Storms that had been dormant begin to stir. All of this happens at a pace that is almost impossible to feel from moment to moment. If you were standing on Saturn, which you couldn't do because there is no surface, but if you could float at the cloud tops and watch, you would not notice the change from one day to the next. Only by comparing 1 year to the next, or 1 decade to the next, would you see the slow turning of the seasons. It's the same way we sometimes don't notice the changes in our own lives until we look back across a span of years and see how different things have become. Saturn lives entirely in that long view. It has no other speed. The tilt of Saturn's axis also affects how we see the planet from Earth. Because Saturn is tilted, and because it moves around the sun, the angle at which we view its rings changes over time. Sometimes the rings are tilted toward us, and we see them as broad, bright bands of light. Sometimes they are edge-on, and they seem to disappear almost entirely. This cycle takes about 15 Earth years from one edge-on appearance to the next, roughly half of Saturn's year. When Galileo first looked at Saturn in the early 1600s, he happened to catch the rings at a time when they were tilted enough to be visible as those mysterious handles. But a few years later, they were edge-on and seemed to vanish. He had no way of knowing this was a regular cycle. He just knew that something strange was happening, something he couldn't explain. Now we understand the pattern. Now we know that the rings will be edge-on again, and then they will tilt open again, and this will continue as long as the rings exist, which may be for a very long time, or maybe for a relatively short time in the life of the solar system. That's one of the unknowns we'll sit with later. For now, let's just rest with the image of Saturn in its orbit, a pale gold planet, ringed with light, moving slowly around the sun, at a distance of 1.4 billion kilometers. Sunlight takes 80 minutes to reach it. Its year lasts nearly 30 of our years. Its seasons stretch across decades. Everything about it speaks of slowness, of patience, of a kind of time that has nothing to do with clocks or calendars or the small urgencies of daily life. When you look up at Saturn in the night sky, you are seeing a world that is living by a completely different clock. The light that reaches your eyes left the planet more than an hour ago. The planet itself is in a different place in its orbit than it was when that light began its journey. Everything is slightly out of sync, slightly behind, slightly delayed. And that delay is not a problem. It's just how things are, out there in the vast, quiet spaces between worlds. So as you lie here in the dark, breathing softly, let your own sense of time stretch out a little. You don't have to keep track of the minutes. You don't have to know what hour it is. The clock by your bed can wait. The schedule for tomorrow can wait. For now you are drifting through the outer solar system, moving at Saturn's pace, slow and steady and unhurried. The sun is a distant point of light behind you. The stars are scattered across the dark like tiny seeds. And ahead, growing slowly larger as we drift, is the soft ringed shape of Saturn, waiting for us to come closer. We'll get there soon enough. There's no rush. The planet has been waiting for 4 billion years. It can wait a little longer, while you breathe and rest and let the journey carry you along. The planet has been waiting for 4 billion years. It can wait a little longer, while you breathe and rest and let the journey carry you along. And as we drift closer now, that soft ringed shape begins to come into focus. The pale gold light we saw from far away is no longer just a point. It grows into a sphere, a world, a place with its own nature and its own strange rules. And the first thing to understand, the most basic thing, is that Saturn is not like Earth. It is not a place you could stand on. It is not made of rock and soil and water. Saturn belongs to a different category of planet altogether, a category we call the gas giants. But before we use that term, let's just describe what Saturn is in plain, simple words. Saturn is enormous. It is a vast sphere made mostly of the lightest elements in the universe, hydrogen and helium. There is no solid surface anywhere on the planet, at least not anywhere you could reach and stand upon. If you were to descend into Saturn's atmosphere in a spacecraft, you would just keep going down and down and down, through clouds and mists and thickening gases, and the pressure would rise, and the temperature would climb, and there would be no moment where you touched down on anything firm. The gas would simply grow denser around you, thicker and heavier, until it became a kind of liquid and then something even stranger beneath that. But there is no boundary, no hard line between atmosphere and ground. Saturn is all atmosphere, all the way down to its deep and hidden core. And this makes Saturn very different from the 4 inner planets. Mercury, Venus, Earth, and Mars are all rocky worlds. They have solid crusts. You could land on them, in theory, and deploy instruments and collect samples of rock. The giant planets are not like that. Jupiter, Saturn, Uranus, and Neptune are all made mostly of gas and ice. They have no surface in the traditional sense. They are more like the Sun in their composition than they are like Earth, though they are much smaller than the Sun, and they do not produce their own light through nuclear fusion. They are sometimes called failed stars, but that phrase is a little misleading. Saturn never tried to become a star. It formed in a different way, from a different part of the cloud of gas and dust that gave birth to the solar system. It is simply a planet of a different kind, a planet made of the same stuff as the stars, but in quantities too small to ignite. Saturn is the second largest planet in the solar system. Only Jupiter is larger. If you could line up all the planets side by side, Jupiter would come first in size, and then Saturn, and then Uranus, and then Neptune, and then the smaller rocky worlds. Saturn's diameter at its equator is about 120,000 kilometers. That's roughly 9 times the diameter of Earth. 9 Earths placed side by side would stretch across the face of Saturn. If Saturn were hollow, which it is not, you could fit more than 700 Earths inside it. The scale of this planet is hard to hold in the mind. It is a world so large that a jet plane flying at cruising speed would take something like 2 weeks to circle it once, if such a thing were possible, which it isn't, because there is nowhere to land and refuel. The sheer size of Saturn is one of its defining features. It dominates its part of the solar system. Its gravity shapes the orbits of its moons and the structure of its rings. Its magnetic field extends far out into space, a vast invisible bubble that interacts with the solar wind. Everything about Saturn is scaled up, stretched out, larger than life. And yet, for all its enormous size, Saturn is surprisingly light. Not light in an absolute sense. The planet as a whole has a mass that is about 95 times the mass of Earth. That's a huge number, a weight that is hard to comprehend. But when you compare that mass to Saturn's volume, when you ask how dense the planet is, how tightly packed its material is, the answer is striking. Saturn is the least dense planet in the entire solar system. Its average density is about 0.7 grams per cubic centimeter. That's less than the density of water. Water has a density of 1 gram per cubic centimeter. Saturn's average density is lower than that. What does this mean in practical terms? It means that if you could find an ocean large enough, a body of water big enough to hold the entire planet, Saturn would float. It would bob on the surface like a giant beach ball, riding high and light. There is no such ocean, of course. The idea is just a thought experiment, a way of understanding how diffuse and spread out Saturn's material really is. But it's a useful image to hold in the mind. A planet so large that it could swallow 700 Earths, and yet so lightly constructed that it would float in water. That contrast between size and density is one of the things that makes Saturn so intriguing. The reason for this low density is Saturn's composition. The planet is made mostly of hydrogen and helium, the two lightest elements in the universe. Hydrogen is the simplest element, with just one proton and one electron. Helium is the second simplest, with 2 protons and 2 neutrons. These are the same elements that make up most of the Sun and most of the stars. They are also the most common elements in the universe as a whole. When the solar system formed, about 4.5 billion years ago, a vast cloud of gas and dust collapsed under its own gravity. Most of that material fell into the center and became the Sun. But some of it formed a spinning disk around the young Sun, and within that disk, particles began to clump together, first into small grains, then into larger bodies, and eventually into planets. Close to the Sun, where it was hot, the lighter elements like hydrogen and helium were boiled away by the intense heat. Only heavier, rockier materials could survive. That's why the inner planets are made mostly of rock and metal. But farther out, beyond what we now call the asteroid belt, it was cold enough for hydrogen and helium and other light materials to stick around. The giant planets formed in this colder region, and they grew enormous by scooping up vast amounts of gas from the surrounding disk. Jupiter, being the closest of the giants to the Sun, grew the largest. Saturn, slightly farther out, grew almost as large but not quite. And the 2 ice giants, Uranus and Neptune, grew smaller still, though they are still vastly larger than Earth. So Saturn is a giant ball of gas, held together by its own gravity, spinning slowly in the cold outer reaches of the solar system. The term for this kind of planet is gas giant. That's the phrase astronomers use to describe Jupiter and Saturn, the 2 largest planets in our system. The word gas tells you what they're made of. The word giant tells you how big they are. But it's worth pausing on the word giant for a moment. It's easy to say, easy to pass over, but Saturn truly is a giant in every sense. Its size is not just a number, it's a physical reality that shapes everything about the planet. The gravity is strong, the pressure in the deep interior is immense, the winds are fast, the magnetic field is powerful. All of this flows from the simple fact that Saturn is very, very large and made of very, very light material and has been shaped by billions of years of physics into the form we see today. If you could look at Saturn up close, without a telescope, just with your own eyes, what would you see? You would see a globe of pale yellow and gold, with bands of slightly different shades running parallel to the equator. The bands are not as vivid as Jupiter's. Jupiter has bright zones and dark belts in shades of orange and brown and cream. Saturn's bands are more muted, more subtle, a watercolor wash of beige and butterscotch and pale amber. The atmosphere is thick and deep, and the clouds that form in its upper layers are made mostly of ammonia ice crystals. These clouds reflect sunlight, giving Saturn its warm, golden glow. The planet is not producing its own light. It shines entirely by reflected sunlight, and because it is so far from the sun, that light is relatively dim. But Saturn is large, and its clouds are reflective, so it still appears bright in our night sky. The rings, of course, add to the brightness, but we will spend time with the rings in their own section. For now, let's just picture the globe itself, a vast sphere of pale gold, banded with soft stripes, spinning quietly in the dark. There is another way to think about Saturn's composition that might help it feel more real. The air you are breathing right now is mostly nitrogen and oxygen, with small amounts of other gases. Saturn's atmosphere is mostly hydrogen and helium. Hydrogen is the gas that once filled airships and dirigibles, the lightest gas there is. Helium is the gas that fills party balloons, the one that makes your voice sound high and squeaky if you inhale it. On Saturn, these gases are not just trace amounts. They are the planet. The whole world is made of them, in quantities so vast that they create a gravitational field strong enough to hold moons in orbit. The hydrogen in Saturn's atmosphere is the same element that powers the sun. The helium is the same element that was first discovered on the sun, before it was found on Earth. Saturn is, in a very real sense, a piece of the sun that didn't quite make it. A fragment of star stuff that coalesced into a planet instead of falling into the central fire. And yet, Saturn is not a star. It is not even close. For a body to become a star, it needs to be massive enough for the pressure and temperature at its core to ignite nuclear fusion, the process that turns hydrogen into helium and releases enormous amounts of energy. Saturn is far too small for that. It would need to be about 80 times more massive than it is to even begin the faintest kind of fusion. So Saturn does not burn. It does not glow with its own light. It simply reflects the light of the sun, a pale gold mirror in the dark, waiting and watching and circling in its slow, patient orbit. Take a slow breath now, and as you breathe out, let yourself imagine the scale of this planet. A sphere of pale gold gas, 120,000 kilometers across, floating in the dark. It is so large that Earth would be a small blue marble beside it. It is so light for its size that it would bob on water. It has no ground, no mountains, no valleys, no oceans of liquid water. Just gas, and more gas, and then stranger things still, deep down where the pressure crushes everything into forms we can barely imagine. That's where we'll go in a later section, down into the depths. But for now, just rest with the image of the globe itself, the soft giant, the ringed world. The planet made of the same stuff as the stars, but too small to burn, Saturn. And somewhere in that vast sphere of pale gold, the sun is setting, and rising and setting again, in a day that lasts just 10.5 hours, while the year stretches on for decades. But that's a story for another part of our journey. For now, just breathe, and let the image of the gas giant float in your mind, soft and slow and steady, like a lantern in the dark. The image of the gas giant floats in your mind, soft and slow and steady, like a lantern in the dark. And now we can turn our attention to something that seems simple, but turns out to be more subtle than you might expect. The passage of time on Saturn. How long is a day there? How long is a night? How does time feel on a world with no solid ground, no mountains to cast shadows, no stable landmarks to track against the sky? These questions lead us into one of the quiet puzzles of planetary science, a puzzle that is not alarming, not urgent, just gently unresolved. On Earth, we know exactly how long a day is. The planet spins at a steady rate, and we can measure that spin by watching the sun rise and set, or by tracking distant stars, or by using precise atomic clocks. The Earth rotates once every 24 hours, more or less. Earth has a solid surface, and we can stand on it, and we can watch the sky turn. We know our day. Saturn is different. Saturn has no solid surface. It is a ball of gas, and different parts of it spin at different speeds. This is one of the first things to understand about time on a gas giant. On a rocky planet like Earth, the whole world rotates as one rigid body. The ground beneath your feet turns at the same rate as the rock deep in the mantle and the iron at the core. Everything moves together. On Saturn, that's not true. The visible cloud tops near the equator rotate at one speed. The cloud tops near the poles rotate at a different speed, and deep inside the planet, where the hydrogen is compressed into strange metallic forms, the rotation rate may be different still. There is no single clock for the whole planet. There are many clocks, all ticking at slightly different rates. So when we ask how long a day is on Saturn, we have to be careful about what we mean. Do we mean a day at the equator, where the clouds whip around the planet fastest? Do we mean a day at the poles? Do we mean the rotation of the deep interior, the hidden core? Scientists have had to wrestle with these questions for a long time, and the answers have shifted over the years as better measurements have come in. What we can say with some confidence is this: at the equator, the visible clouds rotate once every about 10 hours and 14 minutes. That's the speed of the atmosphere in the equatorial zone. At higher latitudes, the rotation period is closer to about 10 hours and 38 minutes. So the clouds at the equator are moving faster than the clouds near the poles. They lap the polar clouds, slowly, over time. But the rotation of the clouds is not the same as the rotation of the planet itself. The clouds are just weather, just winds blowing through the atmosphere. The planet underneath is rotating at its own rate, and figuring out that rate has been one of the great challenges of studying Saturn. On a solid planet, you can just look at the surface. On a gas giant, there is no surface to look at. You have to infer the rotation from other clues. One clue is the planet's magnetic field. Saturn has a strong magnetic field, generated deep within the planet by the motion of electrically conductive material. That magnetic field rotates with the planet's interior. By measuring the radio waves emitted by the magnetic field, scientists can get a sense of how fast the deep interior is spinning. When the Voyager spacecraft flew past Saturn in the early 1980s, they measured radio signals that suggested a rotation period of about 10 hours and 39 minutes. That number was accepted for many years. But when the Cassini spacecraft arrived at Saturn more than 2 decades later, it measured a slightly different period, about 10 hours and 47 minutes. And then later measurements gave slightly different numbers still. This is the puzzle. The rotation period of Saturn's deep interior seems to be shifting, or at least our measurements of it are not consistent. This doesn't mean the planet is speeding up and slowing down in some dramatic way. It more likely means that the radio signals are not a perfect clock. The magnetic field itself may be slipping relative to the deep interior. There may be complex interactions between the magnetic field and the planet's atmosphere, or rings that muddy the signal. Scientists are still working to understand this. The exact rotation period of Saturn's deep interior is not known with perfect certainty, and that's all right. It's just one of those things that the planet has not yet fully revealed to us. There is something restful in that thought. Even a basic fact, like the length of a day, is not fully settled. Saturn keeps its own time in its own way, and it doesn't feel the need to explain itself to us. What we do know is that Saturn spins fast. However you measure it, a day on Saturn is short, about 10.5 hours. That's less than half the length of an Earth day. The sun rises and sets on Saturn in just over 10 hours. If you were floating at the cloud tops, you would see the sun climb quickly into the sky, arc across the golden haze, and then sink below the horizon, all within the span of a single Earth night's sleep. The speed of this cycle is one of the things that makes Saturn feel so different from our own world, where the day stretches out long enough for whole sequences of activity, for morning and afternoon and evening, for the slow fading of light into dark. On Saturn, the light comes and goes in a rush. That fast spin has consequences. It shapes the planet. Saturn is not a perfect sphere. Because it spins so quickly, the planet bulges out at its equator and flattens at its poles. This effect is called oblateness, and Saturn is the most oblate planet in the solar system. The difference between its equatorial diameter and its polar diameter is quite large. The diameter through the equator is about 120,000 kilometers. The diameter through the poles is about 108,000 kilometers. That's a difference of about 12,000 kilometers, which is roughly the entire diameter of Earth. If you could look at Saturn from a distance, you would notice that it is visibly squashed, like a ball of soft clay that someone pressed down from the top and bottom. The rings accentuate this effect because they orbit in the plane of the equator, right around the widest part of the planet. The combination of the flattened globe and the thin, flat rings gives Saturn a distinctive shape, something no other planet quite matches. The fast spin also drives the winds. On Earth, the rotation of the planet helps create the trade winds and the jet streams, the great currents of air that circle the globe. On Saturn, the effect is magnified. The rapid rotation, combined with the lack of a solid surface to slow things down, means that winds can reach very high speeds. We'll talk more about the winds in a later section, when we look at the clouds and the atmosphere in detail. For now, it's enough to know that the short day and the long year create a strange contrast. The planet rushes through its days, one sunrise every 10.5 hours, but it creeps through its years, one orbit every 29.5 Earth years. A day is a heartbeat. A year is a lifetime. The two rhythms don't match at all. Think about what that would feel like, if you could somehow experience it. Imagine a world where the sun races across the sky, where dawn and dusk are brief, where the light changes quickly from one hour to the next. And yet, even as the days flicker past, the seasons barely seem to move. Summer lasts for 7 Earth years. That's about 6,000 Saturn days, 6,000 sunrises, 6,000 sunsets, all while the sun stays high in the northern sky, barely creeping southward. Day after day after day, the same golden light, the same soft haze, the same pattern of clouds drifting by at high speed. And then, so slowly you wouldn't notice it happening, the sun begins to drift lower. The days grow a tiny bit shorter. The light takes on a slightly different quality. After thousands of days, after years of Earth time, autumn arrives, and then the long winter begins, another 7 Earth years, another 6,000 Saturn days, this time with the sun low or absent, the shadows deep, the clouds perhaps changing their patterns in ways we don't fully understand. This contrast between the short day and the long year is not something you need to hold in your mind too tightly. It's just there, part of the strangeness of this world, part of what makes it different from our own. The short day speaks of speed, of motion, of a planet spinning fast enough to flatten itself. The long year speaks of patience, of slow cycles, of a world that takes its time moving around the distant sun. Both things are true at once. Saturn contains both rhythms. It is a fast spinner and a slow walker. It is a world of quick sunsets and decades-long seasons, and it is utterly indifferent to the mismatch. It just continues, doing what it has always done, day after short day, year after long year, for billions of years without pause. There is something in that contrast that can feel restful, if you let it. You don't have to keep a single rhythm. You don't have to be consistent. The planet itself isn't consistent. It rushes and it waits. It spins and it drifts. It holds multiple clocks, and none of them quite agree. If you are lying here in the dark, and your own internal clock feels a little off, if you are not sure whether you are tired or alert, if your body wants to sleep, but your mind is still turning over the events of the day, you are in good company. Saturn doesn't know exactly how long its own day is. The scientists who study it don't know either, not with certainty. And yet the planet continues to spin, and the rings continue to orbit, and the moons continue their steady dance. The not knowing is not a crisis. It's just part of the quiet mystery of things. Take a breath now, a slow one, and as you breathe out, imagine the sun setting on Saturn. The light fades quickly, the golden clouds dimming to amber and then to a deep brownish gray. The stars come out, visible even through the thin high haze. The rings catch the last light of the sun and glow faintly for a while before they too go dark. Then the long night begins, a night that lasts about 5 Earth hours, not quite long enough for a full sleep, but long enough for the atmosphere to cool a little, for the winds to shift, for the planet to turn its face away from the distant sun. And then, in just a few hours, the sun begins to rise again, a new day, another 10.5 hours, another spin of the great wheel. This has been happening day after day for more than 4 billion years. It will keep happening long after we are gone. The rhythm is not ours. It does not answer to us. And that's all right. That's more than all right. That's the very thing that makes it so peaceful to think about. Here in the dark, with our own small clocks ticking quietly beside the bed. Here in the dark, with our own small clocks ticking quietly beside the bed, we can turn our attention inward. Not inward toward ourselves, but inward toward the hidden heart of Saturn. We have spent time with the planet's size, its distance, its place in the solar system, the strange rhythms of its days and years. But all of that has been about the outside, the surface, the parts of Saturn we can see. Now let's go deeper. Let's imagine what lies beneath those pale gold clouds, down where no telescope can see, down where no spacecraft has ever gone. What is Saturn like on the inside? What would you find if you could descend through the atmosphere and keep going, down and down, into the dark? The truth is, we don't know everything about Saturn's interior. Much of what we understand is inferred, pieced together from measurements taken at a distance. No probe has ever plunged deep into Saturn and sent back data from the lower layers. The Cassini spacecraft, which we will talk about in a later section, ended its mission by flying into Saturn's atmosphere, but it burned up and was destroyed long before it reached the deeper regions. What we know about the inside of Saturn comes from indirect evidence. We measure the planet's gravity. We measure its magnetic field. We study how the rings and moons respond to the planet's gravitational pull. From these clues, scientists have built models of what Saturn's interior might be like, and those models, while not certain in every detail, give us a picture that is strange and beautiful and deeply restful to contemplate. Let's begin at the top, at the visible cloud deck. This is the part of Saturn we can see from Earth, the pale gold bands and the soft stripes of beige and cream. The temperature here, at the top of the clouds, is very cold. It's about minus 180 degrees Celsius. That's cold enough to freeze almost anything. The clouds themselves are made mostly of ammonia ice crystals, tiny frozen particles that reflect sunlight and give Saturn its warm golden color. But this is just the outermost layer, the thin skin of the atmosphere. As you go deeper, things begin to change. Descend just a little way into the atmosphere, and the pressure starts to rise. The pressure on Saturn is measured in bars, where 1 bar is roughly the pressure of Earth's atmosphere at sea level. At the cloud tops, the pressure is about 1/10 of a bar, very thin. But as you go down, the weight of all the gas above you presses down harder and harder. After you have descended just a few hundred kilometers, the pressure reaches 1 bar, the same as Earth's surface. After another few hundred kilometers, it's 10 bars, then 100 bars. The pressure rises steadily, relentlessly, with no surface to stop it. And as the pressure rises, the temperature rises too. The gas gets hotter and denser. The ammonia clouds give way to other kinds of clouds, made of ammonium hydrosulfide and then water ice, each layer forming at a different depth where the temperature and pressure are just right. But you wouldn't see these clouds as distinct layers, not the way you might imagine them. The transition from one layer to the next would be gradual, blurry, a slow fading from one kind of cloud to another. The atmosphere is not neatly stacked. It's turbulent and mixed, stirred by the fast winds we'll talk about in the next section, and as you descend further, the light from the sun fades. It gets darker. The golden glow of the cloud tops gives way to a deep twilight, and then to a darkness that never ends. By the time you are a few thousand kilometers down, there is no sunlight at all. The only light comes from the planet itself, a faint glow from the hot interior, maybe occasional flashes of lightning in the deep cloud layers. But mostly, it's dark. dark and hot and under pressures that are hard to imagine. Now, here is where things get strange. As you keep descending, the hydrogen and helium that make up most of Saturn's atmosphere begin to behave in ways that are very different from what we experience on Earth. Hydrogen is normally a gas. It's the lightest gas there is. But under enough pressure, hydrogen stops being a gas and becomes a liquid. Not a cold liquid, the way liquid hydrogen is stored in laboratories on Earth, but a hot, dense liquid, squeezed into a state that doesn't exist naturally on our planet. This transition doesn't happen at a sharp boundary. There is no clear surface where the gas ends and the liquid begins. The hydrogen just gets denser and denser, thicker and thicker, until it is more like a liquid than a gas. It's a gradual change, a smooth blending of states. If you were descending through it, you might not even notice the moment when you crossed from atmosphere to ocean. The substance around you would just grow steadily more dense, more resistant to movement, until you were suspended in a vast sea of liquid hydrogen, hot and dark, stretching for tens of thousands of kilometers in every direction. This is one of the central facts about gas giant planets. There is no surface. There is no sharp line between air and ground, between sky and sea. It's all one continuous fluid, thinning out at the top into the vacuum of space and thickening at the bottom into a dense, metallic ocean. The word ocean here is worth pausing on. We usually think of an ocean as water, a liquid we can see and touch and swim in. On Saturn, the ocean is made of hydrogen, the simplest element, crushed into liquid form by the weight of the planet above it. It's an ocean that is tens of thousands of kilometers deep, an ocean that wraps around the entire planet, an ocean with no shore and no surface and no bottom that you could ever reach. Just liquid hydrogen, going on, getting hotter and denser the deeper you go. And then, deeper still, something even stranger happens. Under truly immense pressure, liquid hydrogen is thought to transform into a state called metallic hydrogen. This is a form of hydrogen that conducts electricity, like a metal. On Earth, hydrogen is never a metal. The pressures required to make it metallic are far beyond what we can produce in any laboratory for more than a brief instant. But inside Saturn, the pressure reaches millions of times the pressure of Earth's atmosphere at sea level. Under those conditions, the hydrogen molecules are squeezed so tightly that the electrons break free from their atoms and flow freely. This creates a liquid that behaves like a metal. It conducts electricity. It generates a magnetic field. Saturn's enormous magnetic field, the invisible bubble that extends far out into space, is thought to be generated in this deep layer of metallic hydrogen, where the planet's rotation stirs the conductive fluid into motion. This layer of metallic hydrogen is not something we can observe directly. No instrument has ever sampled it. No photograph has ever captured it. It is inferred from physics, from our understanding of how hydrogen behaves under extreme pressure, and from measurements of Saturn's magnetic field and gravity. The exact depth where the metallic hydrogen begins is not known with certainty. It might start around halfway down through the planet, or a little deeper, or a little shallower. The details are still being worked out. And that's all right. The not knowing is part of the piece of this subject. We don't need a precise map of Saturn's interior. We can just rest with the general picture, the slow descent from cold cloud tops to liquid hydrogen ocean to metallic hydrogen sea. And at the very center, beneath all those layers of gas and liquid and metallic fluid, Saturn likely has a core. This core is thought to be made of rock and ice, heavy elements that sank to the center during the planet's formation. But even the core is not entirely solid. The temperature at the center of Saturn is estimated to be around 11,700 degrees Celsius, which is hotter than the surface of the Sun. At those temperatures, the rock and ice are not solid in the way we think of rocks on Earth. They are more like a dense, hot slurry, a thick mix of molten material, held together by the enormous pressure from above. The core is not a hard ball. It's a blurry, diffuse concentration of heavy elements, gradually blending into the metallic hydrogen that surrounds it. The size and mass of the core are uncertain. Some models suggest the core is about 10 to 20 times the mass of Earth. Others suggest it might be larger or smaller or more spread out. The Cassini spacecraft's gravity measurements, taken during its final orbits close to the planet, have helped refine these estimates, but they have not settled the question definitively. The data suggests that the core is not a single sharp boundary, but a region where heavy elements are mixed with the metallic hydrogen, a kind of fuzzy core, a gradient rather than a distinct ball. This is another area where the science is not fully settled. And again, that's fine. The planet has no obligation to be simple. It has no obligation to make its inner workings obvious to us. It just is what it is, and we are slowly, patiently learning more about it. Take a moment now to hold this whole picture in your mind, from top to bottom. At the top, the cold cloud layers, pale gold and soft beige, racing around the planet in bands and stripes. And below that, the darkening atmosphere, where the pressure builds and the temperature rises, and the clouds change from ammonia to other compounds. Then the gradual transition to liquid hydrogen, a deep global ocean with no surface and no shore. Then, deeper still, the metallic hydrogen, a strange conductive fluid that generates the planet's magnetic field. And at the center, a hot, dense, fuzzy core of rock and ice, under pressures and temperatures that are almost beyond imagining. That's Saturn. That's what lies beneath the gentle glow we see in the night sky. And here is a thought that might help you rest even more deeply. All of this, all these layers and pressures and strange states of matter have been in place for more than 4 billion years. The core has been hot since the planet formed, and it is still hot, slowly cooling over timescales so long that they make the human lifespan feel like the blink of an eye. The metallic hydrogen has been churning, generating the magnetic field for most of that time. The liquid hydrogen ocean has been circulating, carrying heat from the deep interior up to the cloud tops. The clouds have been forming and dissolving and reforming, ammonia ice crystals condensing and sublimating in an endless cycle. All of this has been going on, day after short day, year after long year, while life on Earth arose and evolved and built civilizations and looked up and wondered. Saturn's interior has been doing its quiet work, unseen, unobserved, for the entire history of our planet, and it will continue doing that work long after we are gone. There is something deeply restful about that thought. Not sad, not lonely, just restful. The universe does not need us to witness it in order to be what it is. Saturn's interior doesn't need to be photographed or sampled or fully understood. It just is. It is a vast, dark, hot, pressurized world within a world, spinning quietly in the outer solar system, holding its secrets close. And we, lying here in the dark, can let those secrets be. We don't have to solve them tonight. We don't have to pin down every uncertainty or fill in every gap in our knowledge. The not knowing is not a problem to be fixed. It's an invitation to wonder, to imagine, to drift through the layers in our minds, without needing to arrive at a final answer. Breathe in slowly, and as you breathe in, imagine descending through those layers. The cold clouds at the top, the darkening sky, the increasing pressure, the gradual thickening of the atmosphere into liquid, the deep, dark ocean of hydrogen, the metallic sea below, the hot, diffuse core at the center, and then breathe out and let the image dissolve. You don't have to hold it all in your head. You can just let it drift, like sediment settling in still water. The planet will still be there tomorrow. Its interior will still be churning. Its core will still be cooling. And you, resting here in the quiet, can let it all be, as you drift a little further toward sleep. You can let it all be, as you drift a little further toward sleep. And now, having traveled down into the dark interior of Saturn, we can rise again, back up through the layers, back through the metallic hydrogen and the liquid ocean and the thickening atmosphere, until we emerge once more at the visible cloud tops. This is the part of Saturn we can actually see, the part that telescopes and spacecraft have photographed and studied. The atmosphere, the weather, the winds and clouds that give Saturn its soft, banded appearance. Here, at the visible surface, The planet puts on a show that is both gentle and wild, slow and fast, simple and deeply strange. When you look at Saturn through a telescope, the first thing you notice after the rings is the color. The planet is pale gold, warm yellow, soft butterscotch. The colors are muted compared to Jupiter's vivid oranges and browns. Saturn's bands are there, stripes of slightly different shades running parallel to the equator, but they are subtle, like watercolors bleeding into each other on wet paper. The boundaries between the bands are not sharp, they blur and fade. One shade of gold drifts into a slightly paler shade, which drifts into a slightly darker shade, and so on around the planet. It's restful to look at. There's nothing harsh or jarring about Saturn's color palette. It's the visual equivalent of a warm lamp in a dim room. The clouds that make up these bands are formed in the upper layers of Saturn's atmosphere, the part we can see from space. They are made mostly of ammonia ice. Ammonia is a simple compound, one nitrogen atom bonded to 3 hydrogen atoms. On Earth, ammonia is a gas at room temperature, a sharp-smelling substance used in cleaning products and fertilizers. On Saturn, the temperatures are so cold that ammonia freezes into tiny ice crystals, the way water vapor freezes into ice crystals in the high clouds of Earth. These ammonia ice crystals are very reflective. They bounce sunlight back into space, which is why Saturn looks bright despite being so far from the sun. The pale gold color comes from the way these crystals scatter light, combined with small amounts of other compounds mixed into the cloud layers. Scientists think that trace amounts of sulfur compounds, phosphorus compounds, or complex organic molecules called tholins may contribute to Saturn's warm tones, but the exact recipe for the color is still not fully settled. There is always some uncertainty, some gentle not knowing in the details of planetary atmospheres. Beneath the ammonia ice clouds, there are other cloud layers made of different materials. Deeper down, where it's warmer, the clouds are thought to be made of ammonium hydrosulfide, a compound that forms a darker brownish layer. Deeper still, where the temperature rises above the freezing point of water, there may be clouds of water ice, or even liquid water droplets. But these lower cloud layers are hidden from view. The ammonia clouds at the top are what we see, and they form a thick, pale blanket that obscures everything below. This is one of the reasons Saturn's bands are so muted. The high ammonia haze softens the contrasts, spreading the light and blurring the edges of the cloud patterns. It's like looking at a painting through a thin layer of gauze. The image is there, but it's gentle, diffuse, easy on the eyes. Now, within this soft and hazy atmosphere, the winds on Saturn are anything but gentle. They are fast, very fast. Saturn has some of the fastest winds measured on any planet in the solar system. Near the equator, winds can reach speeds of up to 1,800 kilometers per hour. That's faster than the speed of sound in Earth's atmosphere, faster than any hurricane or tornado ever recorded on our planet. The winds blow mostly in an eastward direction at the equator, racing around the planet in a great rushing current. At higher latitudes, the winds shift direction, blowing westward in some bands and eastward in others. This pattern of alternating eastward and westward jet streams is similar to what we see on Jupiter, but on Saturn the bands are wider and the transitions between them are smoother. The fast winds are driven by a combination of factors. Saturn spins quickly, which creates strong Coriolis forces that organize the atmosphere into bands. The planet also has a source of internal heat, left over from its formation and from the slow settling of heavier elements toward the core. This internal heat creates convection, the rising and sinking of warm and cool gases, which powers the winds. Unlike Earth, where the sun is the primary driver of weather, Saturn's weather is driven mostly from within. The planet radiates more heat into space than it receives from the sun. It is a world where the weather comes from below, where the deep interior stirs the atmosphere into motion, where the clouds are pushed and pulled by forces rising out of the dark. And yet, for all that speed, Saturn's weather patterns are relatively stable. The bands don't change much over time. The jet streams stay in roughly the same places, year after year. decade after decade. Storms come and go, but the overall structure of the atmosphere is remarkably persistent. There is something restful about that persistence. The winds may be fast, but they are not chaotic. They follow patterns that have been in place for a long, long time. The planet knows what it's doing. It doesn't need to change things up. It just keeps spinning, keeps blowing, keeps circling the sun in its slow, steady way. Occasionally, Saturn does produce larger storms that break the usual pattern. These are called great white spots, and they appear at intervals roughly once every Saturn year, which is about 30 Earth years. These storms can grow to enormous sizes, spreading out into vast white clouds that wrap around much of the planet. They are visible from Earth, and they have been observed for more than a century. The last one appeared in the Northern Hemisphere in 2010 and was studied closely by the Cassini spacecraft. These storms are thought to be caused by the same internal heat that drives the regular winds, building up over time until it breaks through the upper cloud layers in a massive convective outburst. Then the storm slowly fades, and the planet returns to its usual quiet appearance. The cycle repeats, slow and predictable, like a deep breath drawn once every 30 years. But perhaps the most distinctive feature of Saturn's atmosphere, the thing that sets it apart from every other planet we know, is a strange and beautiful pattern at the North Pole. There, surrounding the pole itself, is a jet stream that forms a nearly perfect hexagon, a six-sided shape, each side roughly 13,800 kilometers long, wider than the entire Earth. The hexagon was first seen by the Voyager spacecraft in the early 1980s. When Cassini arrived at Saturn more than 2 decades later, the hexagon was still there, still stable, still rotating with the planet in its slow, steady way. It is one of the most distinctive weather patterns in the solar system, a geometric shape in the clouds of a gas giant. The hexagon is not a solid object. It's a wave pattern in the jet stream, a standing wave that wraps around the pole 6 times. The jet stream itself is moving at high speed, but the wave pattern stays fixed relative to the planet's rotation, creating the appearance of a 6-sided shape. Inside the hexagon, the clouds are generally clearer, and you can see deeper into the atmosphere. At the very center of the hexagon sits Saturn's north polar vortex, a swirling storm that looks like a deep red eye staring out from the middle of the geometric pattern. The combination of the hexagon and the central vortex is strange and beautiful, unlike anything else we have found in the solar system. What causes the hexagon? The honest answer is that scientists don't fully know. It is a phenomenon of fluid dynamics, the study of how liquids and gases move. In laboratory experiments, similar shapes can be created in rotating tanks of fluid when the fluid near the center is spinning at a different rate than the fluid near the edge. This difference in rotation speed creates shear, and the shear can organize into polygonal wave patterns. Triangles, squares, hexagons. The hexagon on Saturn seems to be a naturally occurring example of this kind of fluid behavior, scaled up to planetary size. But the exact details of how it forms and why it is so stable over decades are still debated. The models don't quite match the observations. There is something about Saturn's atmosphere, something about the wind speeds and the temperatures and the deep internal structure that allows this perfect hexagon to persist, and we don't fully understand it yet. This is another one of those places where not knowing can feel restful. The hexagon is there. It has been there for at least 40 years, and probably much longer. It will likely be there for a long time to come. It doesn't need us to understand it. It doesn't need to be explained. It's just a shape in the clouds of a distant planet, a quiet geometric wonder, spinning slowly at the top of the world. You don't have to figure it out. You can just picture it, a pale golden hexagon, wider than the whole Earth, with a dark red storm at its center, turning silently in the cold polar air. It's a good image to hold in your mind as you lie here in the dark, orderly, calm, strange but not threatening, a mystery that doesn't demand a solution. The south pole of Saturn also has a vortex, but it doesn't have a hexagon. The south polar vortex is more circular, with a structure that looks a bit like a hurricane on Earth, though much larger and much more powerful. It has a clear eye at the center, surrounded by high clouds that cast shadows on the cloud deck below. Cassini observed this vortex in detail, watching it spin and shift over the years. But the South Pole lacks the geometric precision of the North. Why the two poles are different is another open question. There is much about Saturn's atmosphere that remains to be understood, and that's fine. The atmosphere doesn't mind being mysterious. It just keeps doing what it does, blowing and swirling and forming strange shapes in the cold, thin air. So let's rest here, at the cloud tops, with the pale gold bands and the fast, quiet winds, and the hexagon turning at the pole. The atmosphere of Saturn is a place of soft colors and hidden depths, of gentle hazes and powerful currents, of patterns that persist for decades and storms that come and go like slow breaths. It is a world of weather without a surface, weather that is driven from deep within, weather that plays out across a globe so large it is hard to comprehend. And yet, for all its size and speed, it is a restful place to imagine. The colors are soft, the patterns are steady, the mystery is gentle. You can let your mind drift across those pale gold bands, following a jet stream around the planet, over the equator, up toward the pole, where the hexagon waits, still and patient, turning in the dark. Take a slow breath now. Imagine the wind on Saturn, not as something violent or frightening, but as a steady current, like a river in the sky. It flows around the planet, smooth and fast, never hitting anything, never crashing against a shore, because there is no shore to hit. It just flows, endlessly, in a circle that has been unbroken for billions of years. And as you breathe out, let yourself be carried by that current, just a little, not fighting it, not trying to steer, just drifting, at the speed of the wind, around the soft golden globe of Saturn, as the stars shine quietly through the haze. Just drifting, at the speed of the wind, around the soft golden globe of Saturn, as the stars shine quietly through the haze. And now, as we circle the planet, we come to the thing that makes Saturn instantly recognizable among all the worlds of the solar system, the rings. The broad, flat, shining rings that wrap around the planet's middle like a halo. They are the reason Saturn looks the way it does in every photograph and every painting. They are the reason Galileo was puzzled by those strange handles. They are the reason Huygens spent night after night at his telescope, trying to understand what he was seeing. The rings are the defining feature of Saturn, and tonight we are going to spend some time with them, up close, in detail, letting their quiet beauty unfold slowly in the dark. Let's begin with what the rings are made of. The rings are not a solid sheet. They are not a single object. They are a collection of countless individual pieces, each one orbiting Saturn on its own path. Almost all of these pieces are made of water ice. Ordinary water, frozen solid, the same substance that forms frost on a winter morning, or ice cubes in a cold drink. But on Saturn, the ice is not pure white. It is mixed with small amounts of rocky dust, which darkens it slightly and gives the rings their subtle variations in color. Some parts of the rings are brighter and more reflective, almost pure ice. Other parts are darker and more muted, where the dust is more concentrated. But everywhere, in every part of the rings, water ice is the main ingredient. The pieces that make up the rings range in size from tiny grains, no larger than a speck of dust, to chunks as big as a house. Most of the pieces are somewhere in between, about the size of a pebble or a golf ball or a fist-sized rock. They are not packed tightly together. There is space between them. If you were to fly through the rings in a spacecraft, you would find that most of the volume is empty space, with the icy particles scattered like a thin mist. From a distance, the rings look solid because there are so many particles, spread across such a vast area, all reflecting sunlight at once. But up close, the rings would resolve into a slow, silent blizzard of ice, each piece drifting in its own orbit, gently colliding and bouncing and tumbling as it circles the planet. The rings are enormous in width. They stretch from about 7,000 kilometers above Saturn's cloud tops out to about 280,000 kilometers from the planet. That's a span of more than 270,000 kilometers from the inner edge to the outer edge. If you placed Earth in the middle of that span, the rings would extend far beyond the Moon's orbit on both sides. The scale is hard to hold in the mind. The rings are wide enough to span most of the distance between Earth and its Moon, and yet, for all that width, the rings are astonishingly thin. In most places, the rings are only about 10 meters thick. 10 meters, that's the height of a 3-story building. Compared to their width of hundreds of thousands of kilometers, the rings are thinner than a sheet of paper relative to its length. If you built a model of the rings where the width was the size of a football field, the thickness would be thinner than a human hair. This extreme flatness is one of the most striking things about the rings. They are a vast, sprawling disk of ice, spanning a distance larger than the gap between worlds, and yet they are almost perfectly flat, a two-dimensional plane of light wrapped around the planet. The rings are not uniform. They are divided into distinct sections, with gaps between them. The main rings, the ones that are visible from Earth with a modest telescope, have been given letter names. This naming system is not poetic, but it is clear. Starting from the innermost main ring and moving outward, there is the D ring, which is very faint and lies closest to the planet. Then the C ring, which is darker and somewhat translucent. Then the B ring, which is the brightest and most massive of all the rings. Then a prominent gap called the Cassini division, named after the astronomer who first observed it in the late 1600s. Then the A ring, which is also bright and broad, though not quite as dense as the B ring. Beyond the A ring, there are fainter rings with their own letter names, like the F ring, the G ring, and the E ring, each one distinct in its structure and origin. The letters don't spell anything. They are just labels, assigned in the order the rings were discovered. There is a quiet orderliness to this system. The rings are simply named, simply organized, moving outward from the planet in their quiet concentric circles. The gaps between the rings are places where the density of particles drops sharply. The most famous gap is the Cassini division, which separates the A ring from the B ring. It is about 4,800 kilometers wide, a dark band that can be seen clearly in photographs of Saturn. The Cassini division is not completely empty. There are particles there, but they are much sparser than in the bright rings on either side. The gap exists because of a gravitational interaction with one of Saturn's moons, a moon called Mimas. Particles in the Cassini division orbit Saturn twice for every one orbit of Mimas. This is called a resonance, a kind of rhythmic gravitational tugging that happens at regular intervals. Over time, the repeated tugs from Mimas clear out the particles from that region, creating the gap. It's a slow, patient process, a gravitational dance that has been going on for millions of years. Other gaps in the rings are created by similar resonances with other moons, or by small moonlets embedded within the rings themselves. The rings are not static. They are constantly being shaped and reshaped by the gravity of Saturn and its moons. Waves ripple through the rings, spiral patterns form and fade, particles clump together and drift apart. The rings are a dynamic place, full of slow motion, even though from a distance they look as smooth and still as a painted disk. This is one of the quiet wonders of Saturn's rings. They seem so serene, so perfect, but up close they are alive with movement, a vast, slow ballet of ice and dust, choreographed by gravity. One of the most remarkable things about the rings is that their origin is not known with certainty. Scientists have ideas, good ideas supported by evidence, but no single explanation has been settled upon. The rings could be leftover material from the early solar system, the same primordial stuff that formed the planets, which never coalesced into a moon because it was too close to Saturn's powerful gravity. Or the rings could be the debris of a moon, or a comet, that wandered too close to Saturn and was torn apart by tidal forces. Or they could be a combination of both, ancient material mixed with more recent fragments. The age of the rings is also uncertain. Some evidence suggests the rings are relatively young, maybe only 100 million years old, which is recent in the life of the solar system. Other evidence suggests they are much older, perhaps as old as Saturn itself. The Cassini spacecraft, during its final orbits, gathered data that supports the younger age, but the debate is not fully resolved. Scientists are still discussing it, still weighing the evidence, still refining their models. This is one of those places where the not knowing can feel especially restful. The rings are there, they are beautiful. They are intricate and complex and full of subtle detail, and we don't know exactly where they came from. We don't know exactly how old they are. We don't know how long they will last. Some models suggest the rings are slowly falling into Saturn, eroded by radiation and micrometeorite impacts, and that they may disappear entirely in another 100 million years or so. Or they may persist for much longer. We don't know. And that's all right. The rings don't need us to know their history. They just are. They shine, they spin. They cast faint shadows on the cloud tops below. They reflect sunlight in a pale, cool glow. And we, lying here in the dark, can simply appreciate them without needing to solve them. Let's spend a little more time with the visual image of the rings. Imagine floating in space just above the ring plane, looking down at the rings from a slight angle. You would see a vast, flat expanse of light, stretching out in all directions. The rings would look like a glowing disk, brightest in the middle, where the B ring sits, and fading gradually toward the edges. The colors would be subtle, mostly shades of white and cream and pale gray, with hints of pinkish brown, where the dust is more concentrated. The Cassini division would appear as a dark gap, a band of relative emptiness separating the bright B ring from the somewhat dimmer A ring. Smaller gaps and ringlets would be visible on closer inspection, delicate structures within the broader bands. And the whole thing would be curved gracefully around the planet, following the line of Saturn's equator, tilting at the same angle as the planet's axis. Now imagine the view from the other side, from the cloud tops of Saturn looking up. You wouldn't see the rings as we see them from afar. You would see them edge on, a thin, bright line stretching across the sky from horizon to horizon. At night, the rings would glow faintly, illuminated by sunlight reflected from the other side of the planet. During the day, the rings would cast shadows on the clouds below, dark bands that move and shift with the seasons. The rings would dominate the sky, a constant presence, always there, always changing their angle and brightness as the planet moved through its long year. It would be a sky unlike anything we can see from Earth, a sky with a permanent arc of light bisecting it, a reminder that you are living on a ringed world. The rings also have their own atmosphere, of a sort. Cassini detected a very thin cloud of oxygen and other gases around the rings, produced when ultraviolet light from the sun hits the water ice and breaks apart the molecules. This atmosphere is incredibly thin, far thinner than the atmosphere of any planet or moon. You couldn't breathe it. You couldn't even measure it without sensitive instruments. But it's there, a faint exhalation from the ice, a ghost of an atmosphere clinging to the rings. The rings also interact with Saturn's magnetic field. The ice particles can become electrically charged, and they can spiral along magnetic field lines, creating faint currents and radio emissions. The rings are not just a passive decoration, they are an active part of the Saturn system, connected to the planet and the moons in ways we are still learning about. Take a slow breath now, and as you breathe in, picture the rings spreading out around Saturn, a vast disk of ice and dust, thin as paper, wide as the distance between worlds. Picture the sunlight filtering through the gaps, casting pale shadows on the golden clouds below. Picture the slow, silent dance of the ring particles, each one following its own orbit, gently jostling its neighbors, forming waves and wakes and spiral patterns that are too subtle for the eye to see, but real nonetheless. The rings have been doing this for millions of years, maybe billions. They will continue doing it for millions more, maybe billions more. They don't need us to watch them. They don't need us to understand them. They are just there, a quiet miracle of geometry and gravity, spinning around a pale gold planet in the outer dark. And as you breathe out, let yourself rest in that image, the rings of Saturn. Not a puzzle to be solved, not a mystery to be unraveled, just a beautiful fact of the universe, glowing softly in the night, waiting for you to notice them, but not demanding that you do. They are patient. They are still. They are exactly where they have always been and where they will always be, at least for the little span of time that we are here to see them. Let that be enough. Let the rings hold you, gently, as you drift a little further toward sleep. Let the rings hold you, gently, as you drift a little further toward sleep. And as we continue to rest here, suspended in the quiet dark near Saturn, we can look a little more closely at the structure of the rings. Not at what they are made of, which we have already talked about, but at how they are shaped, how they keep their form, how the edges stay sharp and the gaps stay clear. Because the rings are not just a random scatter of ice. They are organized, they have order, and that order is maintained by a set of small, quiet moons that work like careful hands, tending the edges of the rings with nothing more than the pull of gravity. These moons are called shepherd moons. The name is a gentle one, and it fits. A shepherd is someone who tends a flock, keeping the sheep together, guiding them along a path, preventing them from straying too far. A shepherd moon does something similar for the ring particles. It orbits near the edge of a ring, and its gravity tugs on the particles that drift too close. The tug is not harsh. It's a slow, steady pull, repeated over and over, orbit after orbit, year after year, until the straying particles are nudged back into line. The shepherd moon doesn't grab hold of anything. It doesn't need to. Gravity does the work, patient and invisible, shaping the rings into the crisp, well-defined structures we see. One of the best-known shepherd moons is a small one called Pan. Pan orbits within the A ring, the outermost of the bright main rings, and it has carved out a gap for itself called the Encke Gap. The Encke Gap is about 325 kilometers wide, a narrow clearing in the dense field of ring particles. Pan sits right in the middle of this gap, and its gravity sweeps the area clean. Any particle that tries to drift into the gap gets a gravitational nudge from Pan, and over time, those nudges add up, and the particle is pushed away. The gap stays open. The edges stay sharp. Pan is not a large moon. It is only about 28 kilometers across at its widest point, small enough that you could drive across it in an afternoon if there were roads. But its gravity, modest as it is enough to maintain order over a region hundreds of kilometers wide. That's the quiet power of shepherd moons. Small things, doing small work, over long stretches of time, and the result is a structure of astonishing precision. Pan itself has a strange shape. Photographs from the Cassini spacecraft show that it looks a bit like a walnut or a flying saucer, with a broad ridge running around its equator. This ridge is made of ring material that has settled onto the moon's surface over time, drawn in by Pan's gravity. So the shepherd moon is not just shaping the ring is also shaping the shepherd moon, draping it in a thin blanket of ice and dust. It's a slow, mutual relationship, a give and take, that has been going on for millions of years. Neither the moon nor the ring is entirely in charge. They shape each other, gently, in a dance that has no end. Another shepherd moon, even smaller than Pan, is called Daphnis. Daphnis orbits inside a narrower gap within the A ring, called the Keeler Gap. It is only about 8 kilometers across, a tiny speck of rock and ice, and yet, its gravity is strong enough to clear the Keeler Gap and to create visible waves in the edges of the gap as it passes. Cassini photographed these waves, delicate ripples in the ring material, like the wake left behind by a slow-moving boat on a still lake. Daphnis also has a ridge around its equator, like Pan, built from ring particles it has collected over time. The symmetry is pleasing. Small moons, small gaps, small waves, all repeating the same patterns at different scales. Outside the main rings, there is a narrow, braided ring called the F ring. The F ring is thin and delicate, and it is tended by two shepherd moons named Prometheus and Pandora. Prometheus orbits just inside the F ring. Pandora orbits just outside it. Together, their gravity pins the ring particles into a narrow band, preventing them from spreading out and dissipating into space. Prometheus and Pandora are sometimes called the shepherd moons of the F-ring, working as a pair to keep the ring in line. But their work is not perfectly smooth. Prometheus, in particular, has an orbit that brings it close to the F-ring at regular intervals, and when it passes, its gravity pulls streamers of material out of the ring. These streamers look like faint, wispy threads drawn out from the main band of the ring and then slowly fading back into the particles. Cassini photographed these interactions in detail, capturing the slow, fluid dance between moon and ring. It's a dynamic system. It changes from one orbit to the next. The F-ring is never quite the same twice. And yet, over the long run, the shepherds keep it contained. The ring persists. The structure holds. This is the gentle work of gravity, playing out over and over again. Gravity is a force we all know. It's what holds us to the ground. It's what keeps the moon in orbit around the Earth and the Earth in orbit around the sun. But on Saturn, gravity does more than just hold things in place. It sculpts, it organizes, it creates patterns. Every gap in the rings, every sharp edge, every wave and ripple and spiral is a product of gravity, working patiently across vast spans of time. The shepherd moons are just the most visible part of this process. There are also resonances, which we touched on briefly in the last section. A resonance is when two objects have orbital periods that form a simple ratio. For example, a particle in the Cassini division orbits Saturn twice for every one orbit of the moon Mimas. This means the particle and Mimas line up at regular intervals, and each time they do, Mimas gives the particle a gravitational tug. The tugs come at the same point in the particle's orbit, over, and over time they amplify, like pushing a child on a swing at just the right moment. The particle's orbit becomes stretched and unstable, and eventually it moves away, clearing out the gap. These resonances create some of the most beautiful structures in the rings. There are spiral density waves, which are regions where the ring particles bunch up into alternating bands of high and low density, like the grooves on a vinyl record. There are bending waves, where the ring plane is gently warped up and down by gravitational forces. There are moonlets, small objects embedded within the rings that are too small to be called moons but large enough to create visible disturbances. The rings are full of these subtle patterns, too faint to see from Earth but visible in the close-up images returned by Cassini. And all of these patterns are made by gravity. The same force that holds you gently in your bed right now is the force that shapes the rings of Saturn. It's a connection that stretches across 1 billion kilometers of space. Gravity, working everywhere, in the same quiet way, linking small things and large things in a single web of cause and effect. The shepherd moons themselves are part of a larger family of small moons that orbit close to Saturn. There are dozens of them, most of them irregular in shape, most of them only a few kilometers or tens of kilometers across. They have names from mythology and literature: Atlas, Epimetheus, Janus, Telesto, Calypso. Each one is a small world in its own right, a lump of ice and rock with its own orbit and its own history. But their individual stories are less important for our purposes tonight than their collective role. Together, they are the caretakers of the rings. They maintain the order, they keep the gaps open and the edges sharp. Without them, the rings would gradually spread out and fade, losing the crisp structure that makes them so beautiful. The shepherd moons are the reason the rings look the way they do, and they have been doing this work for a very long time. There is something deeply calming about the idea of shepherd moons. They don't hurry, they don't strive, they don't make decisions or form plans. They just orbit, following the same paths they have followed for millions of years, and their gravity does the rest. It's a kind of work that requires no effort, no intention, no awareness. The moons don't know they are shepherding anything. They are just there, moving in their orbits, and the physics takes care of the rest. You could say the same about many things in the universe. The sun doesn't intend to shine, the earth doesn't intend to spin, gravity doesn't intend to hold us down. These things just happen because the laws of nature are what they are, and the result is a universe of astonishing order and beauty, including the quiet, well-tended rings of Saturn. So let's rest here for a while with the shepherd moons and their quiet work. Picture Pan, small and walnut-shaped, sitting in the middle of its gap, keeping the edges clean. Picture Prometheus and Pandora, one on each side of the F-ring, holding the narrow band of particles in place. Picture the slow, silent waves that ripple through the rings, the spiral patterns that wind and unwind, the gravitational tugs that nudge particles back into line. All of this is happening right now, at this very moment, while you lie here in the dark. The rings are being tended, the gaps are being maintained, the order is being preserved, not by any conscious effort, but simply by the steady, patient pull of gravity. And you, resting here, are held by that same gravity, the same force that shapes the rings of Saturn. It's a small connection, but a real one. You are part of the same universe. The same laws apply to you. The same gentle persistence that keeps the rings in order is keeping you in your bed, held softly against the surface of the earth, while the night turns slowly around you. Take a slow breath. Let the image of the shepherd moons settle in your mind. Small moons, doing small work, over long stretches of time. There is no rush, there is no deadline. The rings will still be there tomorrow, and the next day, and the next. The shepherd moons will still be tending them, and you, lying here, can let yourself be tended too, by the quiet of the night, by the slow rhythm of your breath, by the gentle pull of sleep. There is nothing you need to do, nothing you need to solve. Just rest, and let the universe do its quiet work, both out there among the rings and in here, in the dark, where your body is slowly letting go. Just rest, and let the universe do its quiet work, both out there among the rings and in here, in the dark, where your body is slowly letting go. And now, having spent time with the rings and the small shepherd moons that tend them, we can widen our view. We can pull back from the rings and look outward, into the larger space around Saturn, where dozens of other moons orbit. Some of them are small, just a few kilometers across. Others are large, worlds in their own right, with atmospheres and oceans and landscapes that are strange and beautiful and utterly unlike anything on Earth. Tonight, we will drift among them slowly, not as a lecture, but as a kind of quiet stargazing, listing them one by one like familiar stars in a well-known sky. Saturn has more confirmed moons than any other planet in the solar system. The number changes from time to time as new moons are discovered and confirmed, but at last count there are more than 140. Some of them are tiny, barely more than captured asteroids, irregular chunks of rock and ice that orbit far from the planet in long, tilted paths. Others are larger, rounder, shaped by their own gravity into spheres, and a few are truly remarkable, worlds that would be famous in their own right if they orbited the Sun instead of hiding in the shadow of a giant planet. We'll start with the largest and work our way down, letting each moon drift into view for a moment before letting it go. Titan is the largest moon of Saturn, and it is a world of its own. It is bigger than the planet Mercury. Its diameter is about 5,150 kilometers, which makes it the second largest moon in the entire solar system, after only Jupiter's moon Ganymede. Titan is large enough that if it orbited the Sun instead of Saturn, we would call it a planet without hesitation. It is a world with a thick atmosphere, the only moon in the solar system to have one. The atmosphere of Titan is made mostly of nitrogen, like Earth's, but mixed with methane instead of oxygen. The methane gives the atmosphere a thick orange haze, like a permanent smog that hides the surface from view. When the Voyager spacecraft flew past Titan in the early 1980s, it could see nothing but that hazy orange globe. The surface was a complete mystery. Later, the Cassini spacecraft carried a probe called Huygens, which descended through Titan's atmosphere and landed on its surface in 2005. What Huygens found was a world that is strange and yet strangely familiar. The surface of Titan is cold, very cold. The temperature is about minus 180 degrees Celsius. At those temperatures, water ice is as hard as rock, and methane can exist as a liquid. And on Titan, liquid methane does what water does on Earth. It forms clouds. It falls as rain. It carves river channels and fills lakes and seas. Titan has a methane cycle, much like Earth's water cycle, with evaporation and precipitation and flowing liquid shaping the landscape. There are lakes of liquid methane and ethane near the poles, some of them as large as the Great Lakes of North America. There are river valleys and floodplains and deltas. There are dunes made of dark organic material, shaped by winds that blow across the surface. Titan is a world of familiar processes but unfamiliar materials, a place where ice is rock and methane is water, and the sky is always orange. The Huygens probe landed on a flat plain, covered with rounded pebbles of water ice, like a dry riverbed on Earth. It sent back photographs of a dim, orange landscape, with rocks scattered across the ground and a hazy sky above. It was the first landing on a moon in the outer solar system, and it remains one of the most distant landings ever attempted. Titan is a quiet world. The gravity is low, about 1/7 of Earth's. The air is thick, about 1.5 times the pressure of Earth's atmosphere at sea level. If you were standing on Titan, you could walk slowly through the dim orange light, your footsteps crunching on the icy gravel, the distant shores of a methane lake glinting faintly in the haze. There is something deeply restful about imagining Titan. It is a world of slow processes and muted colors, a place where change comes gradually and nothing hurries. Another moon, much smaller than Titan but equally remarkable in its own way, is Enceladus. Enceladus is a small icy moon, only about 500 kilometers across. It is small enough that you could drive across it in a few hours. And yet, this tiny moon has become one of the most important objects in the solar system for scientists who study the possibility of life beyond Earth. Enceladus is covered in a shell of clean, bright ice, the most reflective surface in the solar system. It shines like fresh snow. But beneath that icy shell, something remarkable is happening. At the south pole of Enceladus, there are long cracks in the ice, sometimes called tiger stripes, because of their parallel, stripe-like appearance. From these cracks, geysers of water vapor and ice particles erupt into space, shooting up hundreds of kilometers above the moon's surface. Cassini flew through these plumes and sampled the material. What it found was water, mixed with salt, organic molecules, and tiny grains of silica sand. All of these things suggest that beneath the icy shell of Enceladus, there is a global ocean of liquid water, kept warm by tidal heating from Saturn's gravity. And where there is liquid water, there is at least the possibility of conditions suitable for life. This does not mean there is life on Enceladus. We don't know. We have not found any. But the ingredients are there: water, organic molecules, a source of energy from the tidal flexing that keeps the ocean warm. It is a quiet, tantalizing possibility, and it makes Enceladus one of the most intriguing places in the solar system. The geysers themselves are a beautiful image to hold in the mind. Imagine standing on the surface of Enceladus, under the black sky of space, with Saturn and its rings looming huge overhead. And from the cracks in the ice, silent fountains of water vapor rise up, glittering in the distant sunlight, spreading out into a faint haze that slowly drifts away into space. It would be a scene of great stillness and great beauty, a quiet fountain on a tiny moon, far from everything we know. Then there is Mimas, another small moon, but memorable for a different reason. Mimas has a giant crater on its surface, a crater so large that it makes the whole moon look like a giant eye staring out into space. Or, as some people have noted, like the Death Star from a famous science fiction film, though that resemblance is a coincidence of timing. The crater is called Herschel, after the astronomer who discovered Mimas in the late 1700s. It is about 130 kilometers across, which is nearly a third of the moon's entire diameter. The impact that created Herschel must have nearly shattered Mimas apart. The shock waves from the impact can be seen on the opposite side of the moon, where the surface is fractured and cracked. Mimas is a survivor, a small world that took a massive blow and held itself together. And now it just orbits, quietly, its great crater facing forward or backward or sideways, depending on where it is in its path around Saturn. There are other moons worth noting, each with its own quiet character. Iapetus is a moon with a strange two-tone surface, one hemisphere dark and the other bright, like a cosmic yin and yang symbol. The dark side is covered in a layer of reddish dust, thought to have come from another moon called Phoebe, which orbits farther out. Iapetus also has a ridge of mountains running along its equator, making it look a bit like a walnut in some photographs. Hyperion is a moon that looks like a sponge, covered in deep craters and irregular in shape. It tumbles chaotically as it orbits, its rotation unpredictable, one of the few objects in the solar system that does not spin in a stable, predictable way. Dione and Rhea are medium-sized moons, round and icy, covered in craters and canyons and scarps. Tethys has a giant canyon called Ithaca Chasma that wraps much of the way around the moon, a scar from some ancient geological event. All of these moons, and many more, orbit Saturn in their own paths, at their own speeds, some close to the planet and some far away. They range in size from Titan, a world larger than Mercury, down to tiny moonlets just a few kilometers across. Some of them share orbits, like Janus and Epimetheus, which swap places every 4 years in a slow, gravitational dance. Some of them are captured asteroids, objects that wandered too close to Saturn long ago and were pulled into orbit. Some of them are fragments of larger moons that were shattered by impacts. Each one has its own story, its own history, its own quiet presence in the Saturn system. But tonight, we don't need to learn all their stories. We don't need to memorize their names or their sizes or their orbital periods. We can just list them softly, like naming stars in a familiar constellation. Titan, with its orange sky and methane lakes, Enceladus with its icy geysers and hidden ocean, Mimas with its great staring crater, Iapetus, dark on one side and bright on the other, Dione, Rhea, Tethys, Hyperion, Phoebe, Janus, Epimetheus. They are all out there, right now, circling the pale gold planet in their quiet, steady way. They have been doing this for billions of years. They will continue for billions more. They don't know we are here. They don't need us to know about them. They are simply there, a family of small worlds, each one different, each one quiet, each one reflecting the distant sunlight as they move through the dark. There is something comforting about that. The sheer number of moons, the quiet persistence of their orbits, the fact that Saturn holds all of them, large and small in its gravitational embrace, and they all move together in a pattern that has been stable for most of the history of the solar system. It's a reminder that there are many ways to be a world. You don't have to be large. You don't have to be close to the sun. You don't have to have an atmosphere or an ocean or a landscape of rivers and mountains. You can just be a small lump of ice, a few kilometers across, orbiting quietly in the outer dark, and you are still part of the great pattern. You still matter to the gravitational equations. You still have a place. Take a slow breath now, and as you breathe in, picture the moons of Saturn spread out around the planet, like a scattered handful of seeds. Some are large and round, some are small and irregular, some are bright and reflective, some are dark and dusty. All of them are moving, each in its own orbit, each at its own pace, a great slow clockwork of moons that has been ticking for billions of years. And as you breathe out, let yourself rest in that image. The moons don't hurry, they don't compete, they don't compare themselves to each other. They just orbit, they just are. And you, lying here in the dark, can be a little like a moon of Saturn tonight, quiet, patient, held in place by forces larger than yourself, drifting slowly along your own path, in your own time, as the night turns gently around you. Quiet, patient, held in place by forces larger than yourself, drifting slowly along your own path, in your own time, as the night turns gently around you. And now, having spent time with the moons of Saturn, those distant worlds that circle the planet in their quiet orbits, we can turn our attention to a different kind of journey. Not the journey of a moon, but the journey of human-made machines, small, purposeful craft that we built and launched across the vast distance between Earth and Saturn, carrying cameras and instruments, and the hopes of the people who wanted to see this ringed world up close. These missions took years, decades, lifetimes to plan and execute, and they brought back everything we know about Saturn in fine detail. Tonight, we'll drift through the story of those missions, slowly, the way a spacecraft drifts through the outer solar system, conserving its energy, taking its time. The first spacecraft to visit Saturn was a small, pioneering probe called Pioneer 11. It was launched from Earth in April of 1973, and it took a long, curving path through the solar system. It flew past Jupiter first, using Jupiter's gravity to bend its trajectory outward towards Saturn. This is a common technique in space travel. By flying close to a planet, a spacecraft can steal a little of the planet's orbital momentum, gaining speed and changing direction without using any fuel. It's called a gravity assist, and it's one of the reasons we can send probes to the outer planets at all. Pioneer 11 used Jupiter to slingshot itself towards Saturn, and on September 1, 1979, it made its closest approach to the ringed planet. It passed within about 21,000 kilometers of Saturn's cloud tops, which is very close in astronomical terms. It sent back the first close-up images of Saturn ever taken by a spacecraft. The pictures were low resolution by modern standards, but they showed the rings and the cloud bands and a few of the larger moons. Pioneer 11 confirmed that Saturn's rings were made of many separate particles, not a solid sheet, by measuring how radio signals passed through them. It also discovered a faint outer ring that had not been seen from Earth. And then it kept going, drifting outward into the darkness, eventually falling silent decades later as its power source faded. Pioneer 11 is still out there, somewhere in the space between the stars, carrying a small plaque that shows a map of our solar system and the figures of a man and a woman. It will drift for billions of years, a quiet ambassador from a small blue planet. Just a year after Pioneer 11 flew past Saturn, another spacecraft arrived. Voyager 1 reached Saturn in November of 1980. It had been traveling for more than 3 years, having launched from Earth in September of 1977. Voyager 1's cameras were better than Pioneer's, and the images it sent back were far more detailed. It showed the rings in unprecedented clarity, revealing the complex structure of gaps and ringlets that we talked about in earlier sections. It photographed Titan, Saturn's largest moon, though the images were frustrating because Titan's thick atmosphere obscured its surface. The scientists were so intrigued by Titan that they adjusted Voyager 1's path to fly closer to the moon, a decision that had consequences. The close flyby of Titan bent Voyager 1's trajectory upward, out of the plane of the solar system, and the spacecraft could not visit any more planets after Saturn. It began its long journey into interstellar space, where it is now, still transmitting faint signals back to Earth, more than 40 years after its launch. Voyager 2 followed about 9 months later, arriving at Saturn in August of 1981. Because Voyager 1 had already taken the close look at Titan, Voyager 2 was free to take a different path. It flew past Saturn and then continued on to Uranus and Neptune, becoming the only spacecraft to visit those distant ice giants. Voyager 2's images of Saturn added more detail to what Voyager 1 had seen. The two Voyagers together mapped the rings, measured the winds, counted the moons, and transformed our understanding of the Saturn system. They found new moons, they found new rings, they measured the planet's magnetic field and studied its atmosphere. They did all of this with technology that was, by today's standards, quite primitive. The Voyager spacecraft each had less computing power than a modern pocket calculator, and yet they traveled billions of kilometers, and they worked, and they sent back images that still hold up decades later. But the great mission to Saturn, the one that truly opened the planet to human understanding, was Cassini. Cassini was a joint project between NASA, the American Space Agency, and ESA, the European Space Agency, along with contributions from the Italian Space Agency. It was a large spacecraft, about the size of a small school bus loaded with instruments. It launched from Earth in October of 1997, and it took a long, looping path through the inner solar system to build up speed. It flew past Venus twice. It flew past Earth once, swinging by our own planet to get a gravitational boost. It flew past Jupiter, taking pictures of the giant planet along the way. And then, after nearly 7 years of travel, it arrived at Saturn in July of 2004. Cassini did not just fly past Saturn. It entered orbit. It became a moon of Saturn, a human-made moon, circling the planet in a long, elliptical path. And it stayed there for more than 13 years. From 2004 to 2017, Cassini orbited Saturn, taking photograph after photograph, measurement after measurement. It watched the rings from every angle. It tracked the storms in the atmosphere. It discovered new moons, some of them embedded within the rings themselves. It carried the Huygens probe, which landed on Titan and sent back those haunting images of an orange landscape with rounded pebbles of ice. Cassini flew through the geysers of Enceladus and tasted the water. It measured the gravity of Saturn and mapped the interior structure we talked about in an earlier section. It watched the seasons change on Saturn, slowly, over the course of its long stay. When Cassini arrived, it was winter in the northern hemisphere. By the time it finished, summer had come to the north, and the rings had tilted from one angle to another. The sheer volume of data Cassini returned is hard to comprehend. More than 450,000 images, countless scientific papers, a complete rethinking of what we knew about Saturn, its rings, and its moons. Before Cassini, much of what we thought we knew was sketchy, based on brief flybys and distant telescope observations. After Cassini, we had a detailed, intimate portrait of the entire Saturn system. It was one of the most successful planetary missions in history, not because it made any single dramatic discovery, but because of its patience. It stayed, it watched, it observed the same things over and over, building up a record of change over time. It was the opposite of a quick visit. It was a long, slow, careful study, and that slowness was its greatest strength. The end of Cassini's mission was planned from the beginning. The spacecraft was running out of fuel. Its power source, which relied on the decay of radioactive plutonium, was gradually fading. The mission team had to decide how to end the mission safely. They did not want Cassini to drift uncontrolled and possibly crash into one of Saturn's moons, especially Enceladus or Titan, which might have environments suitable for life. Contaminating those moons with Earth microbes, even by accident, was something they wanted to avoid. So they chose a deliberate final path. They sent Cassini on a series of close orbits that threaded the gap between the rings and the planet's cloud tops, a region no spacecraft had ever visited. These were called the grand finale orbits. Cassini flew through the narrow space between Saturn and its rings 22 times, gathering data right up to the end. And then, on September 15, 2017, Cassini made its final plunge. It angled itself toward Saturn and entered the atmosphere. It transmitted data as long as it could, its thrusters fighting to keep its antenna pointed at Earth, until the increasing pressure and heat overwhelmed it. It burned up in the atmosphere of Saturn, becoming part of the planet it had studied for so long. There is something deeply moving about that ending, but not in a sad way. It was a quiet, deliberate finish to a quiet, deliberate mission. Cassini didn't crash by accident. It wasn't lost. It completed its work and then gently let go, merging with the planet it had orbited for 13 years. It is still there, in a sense. The atoms that made up Cassini are now part of Saturn's atmosphere, drifting through the pale gold clouds, carried by the fast winds, slowly sinking into the depths we imagined in an earlier section. The spacecraft became the thing it studied. That's not a tragedy, it's a kind of homecoming. And here, in the quiet of this night, There is a connection between Cassini's slow, patient work and your own slow drift towards sleep. Cassini took its time. It didn't rush. It orbited Saturn again and again, watching, waiting, accumulating a record of gradual change. It did not need to be fast to be effective. Its slowness was not a flaw. It was the whole point. In the same way, your own rest tonight does not need to be fast. You don't need to fall asleep quickly. You don't need to force anything. You can just orbit quietly in the dark, letting the hours pass at their own pace. Cassini took 13 years to complete its mission. You have an entire night. There is no hurry. The missions to Saturn, from Pioneer to Voyager to Cassini, represent a certain kind of human achievement. Not the kind that shouts, not the kind that demands attention, but the kind that plans carefully, works patiently, and waits years or decades for results. The scientists who worked on Cassini were young when the mission launched, and near retirement when it ended. Some of them didn't live to see the final results. They did the work anyway, because the work was worth doing, even if the payoff was far in the future. There is something restful in that too. The idea that not everything needs to be done quickly, that some things are worth waiting for, that patience is not just a virtue but a practical necessity, built into the scale of the solar system itself. Take a slow breath now, and as you breathe in, think of all those spacecraft still out there in the dark. Pioneer 11, drifting silently beyond the orbit of Neptune. Voyager 1 and Voyager 2, farther still, sending back faint signals from interstellar space. Cassini, dissolved into the atmosphere of Saturn, its atoms mingling with the clouds it photographed so many times. All of them traveled immense distances, across spans of time that are hard to grasp, and they did it quietly, without fanfare, 1 kilometer per second at a time. They are still traveling, most of them. They will keep traveling long after we are gone, and the data they sent back is still being studied, still yielding new insights, still giving us images to hold in our minds on quiet nights like this one. As you breathe out, let yourself be a little like Cassini tonight, patient, steady, doing the quiet work of rest, without hurry, without expectation. The mission of sleep does not need to be completed by any particular hour. It can take as long as it takes. You can orbit around the edge of sleep for a while, gathering data, taking in the quiet, before you make your final descent. And when you do, it will be gentle. It will be deliberate. It will be the natural end of a long, slow journey through the dark. The spacecraft did their work. Now you can do yours. Rest and let the night carry you, the way Cassini was carried by the gravity of Saturn, in a long, slow, graceful arc toward morning. Rest and let the night carry you, the way Cassini was carried by the gravity of Saturn, in a long, slow, graceful arc toward morning. And now, as we approach the end of our journey together, it is time to gather up the things we do not know, not to solve them, not to explain them, just to hold them, gently, the way you might hold a smooth stone you found on a walk, turning it over in your hand without needing to know where it came from. The unknowns about Saturn are not failures of science. They are not gaps that need to be filled urgently. They are simply the edges of our understanding, the places where the map fades into soft gray and the words become less certain. And in the quiet of this night, those edges can feel restful. They can feel like open space, like room to breathe. Let's begin with the rings, because they are the most visible mystery. We have talked about what the rings are made of, how they are shaped, how they are tended by shepherd moons, but we have not settled the question of where they came from. The origin of Saturn's rings is not known with certainty. There are two main ideas, and scientists have not been able to agree on which one is more likely. The first idea is that the rings are very old as Saturn itself. In this view, the rings formed from leftover material that was present when the solar system was young. Some of the gas and dust that surrounded the early sun never coalesced into moons or fell into the planet. Instead, it formed a disk of debris that has persisted for more than 4 billion years, gradually settling into the rings we see today. If this is true, The rings are ancient, stable, and have been a feature of Saturn for most of its history. The second idea is that the rings are relatively young, perhaps only 100 million years old or so. In this view, the rings formed when a moon or a comet wandered too close to Saturn and was torn apart by the planet's powerful gravity. The debris from that destruction spread out into a disk, and over time it settled into the ring system we see today. If this is true, the rings are a temporary feature, a brief moment of beauty in the long life of Saturn. 100 million years sounds like a long time to us, but compared to the 4.5 billion year age of the solar system, it is just a fraction. The dinosaurs were alive on Earth 100 million years ago. The rings, in this scenario, may not have existed when Saturn first formed. They may not exist in the far future. They are a passing phase, a fleeting ornament, and we happen to be alive at the right time to see them. The evidence is mixed. Cassini measured the mass of the rings by flying between them and the planet during its final orbits. The rings are more massive than some earlier estimates suggested, which could support an older age. But Cassini also measured the rate at which dark dust from outside the Saturn system is falling onto the rings. The rings are still quite bright and reflective, which suggests they have not been accumulating dust for billions of years. If they were ancient, they might be darker, more discolored by the slow rain of cosmic dust. The debate continues. Scientists are still analyzing the data, still refining their models, still presenting arguments for one side or the other. And in the meantime, the rings just shine. They don't care how old they are. They don't need us to settle the question. They are there, and we can see them, and that is enough. Another unknown concerns the interior of Saturn. We talked about this in an earlier section, but it is worth restating here, in the context of all the other things we do not know. The precise nature of Saturn's core remains uncertain. We know there is a concentration of heavy elements at the center. We know it is hot and under enormous pressure, but we do not know exactly how large the core is, or exactly what it is made of, or whether it has a sharp boundary or a fuzzy one. The measurements from Cassini suggest that the core is not a distinct solid ball, but rather a diffuse region where heavy elements are mixed with the metallic hydrogen that surrounds it. But this is an inference, not a direct observation. No instrument has ever sampled the core. No spacecraft has ever seen it. We are looking at Saturn from the outside and trying to understand its deepest interior through indirect clues. Gravity measurements, magnetic field measurements, models of how hydrogen behaves under extreme conditions. These are good tools, and they give us a reasonable picture, but the picture is blurry around the edges. There is room for doubt, there is room for revision, and that's all right. The core of Saturn is under no obligation to be simple. It can be as strange and complex as it wants. We will learn more, slowly, over time. Or we won't. Either way, Saturn's interior will continue its quiet work, hidden from view, undisturbed by our questions. Then there is the mystery of Enceladus. We know that Enceladus has a global ocean of liquid water beneath its icy shell. We know that geysers at the South Pole spray water vapor and ice particles into space. We know that this water contains salt and organic molecules and tiny grains of silica sand, all of which suggest that the ocean is in contact with a rocky seafloor where chemical reactions could provide energy for living things. But we do not know whether there is life in that ocean. We have not found it. We have not ruled it out. The question remains open, and it may remain open for a very long time. Sending a mission to Enceladus that could directly sample the ocean and search for signs of life would be difficult and expensive and slow. It would take decades to plan, launch, and arrive. And even then, the results might not be clear. Life might be there but too sparse to detect. It might be there but too different from Earth life for our instruments to recognize. It might not be there at all. We simply do not know. And this not knowing is not a source of frustration. It is a source of quiet wonder. The possibility is there. The ocean is there. The geysers are there. Enceladus is doing what it does, spraying its water into space, and we can look at it and wonder, without needing to settle the question tonight. The hexagon at Saturn's North Pole is another open question. We know it exists, we have seen it, photographed it, measured it, but the exact mechanism that creates and maintains that perfect six-sided shape is still debated. Fluid dynamics can produce similar shapes in laboratory experiments, but the conditions on Saturn are not identical to the conditions in a lab. The hexagon is larger, more stable, more long-lived than the models would predict. There is something about Saturn's atmosphere, some combination of wind speeds and temperatures and deep internal forces, that allows this geometric wonder to persist. Scientists are working on the problem, but it is not fully solved. And again, the hexagon does not need to be solved to be appreciated. It is there, it is beautiful, it is strange. You can hold it in your mind as a quiet mystery, a shape in the clouds of a distant planet, turning slowly at the top of the world. The rotation period of Saturn's deep interior is another gentle unknown. We talked about this in the section on Saturn's day. The clouds at different latitudes rotate at different speeds. The magnetic field rotates at a speed that seems to shift over time. The true rotation of the planet's core is not pinned down with absolute certainty. There is a number, but it has error bars around it. It is known within a range, not known to the last decimal place. This is a reminder that even basic facts about a planet can be elusive. Saturn is not a simple object. It is a complex, fluid, dynamic world, and its deepest rhythms are hidden from us. We can measure and model and estimate, but we cannot know with perfect precision, and that's fine. The planet spins at whatever speed it spins. Our uncertainty does not affect it. It just continues, day after short day, year after long year, keeping its own time in its own way. What ties all of these unknowns together is a certain kind of humility. We have learned a great deal about Saturn. We have sent spacecraft across more than 1 billion kilometers of space. We have taken photographs of the rings from a few thousand kilometers away. We have landed a probe on Titan and tasted the plumes of Enceladus. We have measured the gravity and the magnetic field, and the winds and the clouds. And yet, after all of that, there are things we do not know, fundamental things, the age of the rings, the nature of the core, the possibility of life in a hidden ocean, the cause of a polar hexagon, the exact length of a day. These are not trivia. These are deep questions about the nature of a world, and we do not have the answers, not yet, maybe not ever. This is not a cause for alarm. It is not a sign of failure. It is simply the nature of the universe. It is large, and we are small. It is old, and we are new. It does not owe us explanations. We have to earn them, slowly, over time, through patience and care and the steady accumulation of knowledge. And even then, some things will remain hidden, some mysteries will persist, and that, too, is part of the peace of space. The unknown is not a void that must be filled. It is a quiet presence, a companion on the journey, a reminder that there is always more to see and learn and wonder about. Take a slow breath now, and as you breathe in, let yourself sit with these unknowns. The age of the rings, uncertain. The core of Saturn, fuzzy and inferred. The ocean of Enceladus, possibly alive, possibly not. The hexagon, geometrically perfect, causally mysterious. The rotation period, approximate. All of these things are real, and all of them are unresolved. And yet Saturn continues to orbit. The rings continue to shine. The moons continue their quiet dance. The unknowns do not stop the universe from being beautiful. They do not stop you from resting. If anything, they make the rest deeper. They give the mind something soft to rest against, a boundary that does not need to be crossed. As you breathe out, let the questions drift away. You don't need to answer them. You don't need to hold on to them. You can just acknowledge them and then let them go. They will still be there tomorrow. The scientists will still be working on them. The spacecraft data will still be analyzed. The models will still be refined. And you, lying here in the dark, can simply let the not knowing be. It is not a problem to solve. It is part of the night, part of the quiet, part of the soft, dark blanket that wraps around you as you drift towards sleep. The universe is full of things we do not know. That is not a flaw. That is one of the things that makes it so restful to think about. Here in the dark, where the only task left is to breathe and let go and allow the mystery to be exactly what it is. Here in the dark, where the only task left is to breathe and let go and allow the mystery to be exactly what it is. And so we arrive at the last part of our journey together. Not an ending, really. Endings are too sharp, too sudden for a night like this, more like a gentle turning away, a slow release of attention, a quiet return to where we began. No new facts now, no new names or numbers or measurements. Just a soft revisiting of an image we have been holding all along, now seen a little differently, now understood a little more, but still, at its heart, the same pale gold light it has always been. Do you remember the very beginning, before the numbers, before the distances and the diameters and the orbital periods, before the spacecraft and the moons and the hexagon at the pole? There was just a point of light in the night sky, a soft, steady glow that didn't twinkle like the stars, a light that ancient watchers saw and named and folded into their stories. That light was Saturn. It is still Saturn. Everything we have talked about tonight, all the layers and rings and moons and mysteries, all of it is contained in that single point of light that you can see with your own eyes on a clear night. The same light that touched the eyes of Galileo and Huygens and Cassini. The same light that left the planet more than an hour before it reached you, traveling across 1 billion kilometers of empty space, just to arrive at this moment, in this room, as a pale gold glow in the dark. Nothing about that light has changed. Saturn is still there. It is still orbiting the sun in its slow, patient way, taking nearly 30 years to complete a single circuit. Its rings are still shining, a vast, thin disk of ice and dust, tended by small shepherd moons that ask for nothing in return. Its clouds are still blowing, fast and steady, tracing bands of muted gold and pale yellow around the globe. The hexagon is still turning at the North Pole. The geysers of Enceladus are still erupting, sending faint plumes of water vapor into the blackness of space. Titan's methane lakes are still glinting under their orange haze. All of it is still happening, right now, while you lie here in the quiet. The planet does not need you to witness it, but you have witnessed it, in your own way, by listening, by imagining, by letting your mind drift across the distance to that distant world. And now, as we prepare to let the journey go, we can return to that first image, the soft ringed light in the night sky. But now you know a little more about what that light contains. You know that it is a giant made of gas, mostly hydrogen and helium, with no solid surface to stand on. You know that it is so large it could swallow 700 Earths, and so light for its size that it would float in water. You know that a day there lasts only 10.5 hours, but a year stretches on for nearly 3 decades. You know that beneath the visible clouds, the pressure builds and the hydrogen becomes a liquid, and then a metal, and at the center there is likely a core of rock and ice, though no one has seen it directly. You know that the rings are made of countless pieces of water ice, ranging from tiny grains to chunks the size of houses, and that they are thinner than a sheet of paper relative to their width. You know that small moons tend the edges of the rings, keeping them sharp and orderly, through nothing more than the patient pull of gravity. You know that Titan has an atmosphere and lakes of liquid methane. You know that Enceladus has a hidden ocean and geysers of water vapor. You know that humans have sent spacecraft across that immense distance, and one of them, Cassini, stayed for 13 years before gently letting go and becoming part of the planet it studied. But knowing all of that does not change the essential thing. Saturn is still a point of light in the night sky. It is still beautiful in a way that does not depend on understanding. You could know nothing about Saturn, and it would still be beautiful. You could know everything we have learned, and it would still be mysterious, because there is so much we do not know. The age of the rings, the nature of the core, the possibility of life in a hidden ocean. These open questions do not diminish the beauty, they add to it. They give the mind a place to rest, an edge to lean against, a soft boundary where knowledge fades into wonder. And now, slowly, we can begin to let Saturn go, not forgetting it, just releasing it, letting it drift back into the night sky where it belongs, a pale gold light among the stars. It has been a good companion for this journey, patient, calm, unhurried. It has asked nothing of you except your attention, and even that it did not demand. It just waited, the way it has always waited, for anyone who cared to look up and wonder. You have looked up, you have wondered, and now you can rest. Let your attention turn gently away from the distant planet and back toward yourself. Not sharply, not suddenly, just a slow, easy shift, like a boat turning in still water. Feel the weight of your body on the bed. Feel the softness of the pillow under your head. Feel the slow rise and fall of your chest as you breathe. You have been traveling a long way tonight, across billions of kilometers of space and thousands of years of human history. But you have not moved at all. You have been here the whole time, warm and still, and the journey has been an inward one, a journey of imagination and attention. Now the journey is ending and the traveler is coming home. Your breathing is slow and easy, in and out, each breath a little softer than the one before, each breath carrying you a little further from the shore of waking. The room around you is quiet, the night outside is dark. Somewhere, beyond the ceiling and the roof and the thin blue atmosphere, the stars are shining. Saturn is among them, a steady point of gold, doing what it has always done. But you don't need to think about Saturn anymore. You have spent enough time with it. It will still be there tomorrow night, and the night after that, and every night for the rest of your life. You can visit it again whenever you want, just by closing your eyes and remembering. For now, there is nothing left to do, no more facts to absorb, no more images to hold in your mind, no more questions to turn over. Just the slow, quiet drift into sleep. The body knows how to do this. It has been doing it since you were born. You don't need to help it. You don't need to control it. You can just let it happen. The way Saturn lets its rings be tended by shepherd moons, the way the clouds let the winds carry them, the way Cassini let gravity pull it gently into the atmosphere at the end of its long mission. Surrender is not failure. It is the natural end of all things that have completed their work. The sentences are growing shorter now. The pauses are growing longer. The voice that has been speaking to you is fading into the background, becoming less distinct, like a radio signal from a distant spacecraft, still there, but harder to hear. You don't need to follow the words anymore. You can let them wash over you like water, or like wind, or like the faint rustle of ring particles brushing against each other in the dark. The meaning will take care of itself. Your only task now is to let go. Remember the very first image. The one from the beginning, the soft ringed light in the night sky. You know that light now. You have traveled toward it, around it, through it, and back again. And now you are returning from it, the way a spacecraft returns from a long mission, carrying data and images and memories. But unlike a spacecraft, you don't need to transmit anything. You don't need to report what you have seen. You can just hold it inside you, a quiet knowledge, a warm presence, as you drift the rest of the way into sleep. Saturn will be there when you wake. The rings will still be shining. The moons will still be orbiting. The hexagon will still be turning. The mysteries will still be unsolved. And you will still be here, on this small blue planet, held by the same gravity that shapes the rings, breathing the same elements that make up the stars. The connection does not break. It just grows quiet. It just rests as you are resting now. So let the last image fade. The pale gold planet, the thin bright rings, the small shepherd moons, the orange haze of Titan, the icy plumes of Enceladus. Let them all go, gently, one by one, like lights being turned off in a quiet house. The only light left is the one inside you, the small warm glow of your own awareness, and even that is dimming now, softening, preparing to go out for a while. Not forever, just for the night, just long enough to rest. Just long enough to let the body and the mind renew themselves, the way Saturn renews its storms with each long season, the way the rings renew their particles with each gentle collision. Breathe in slowly, breathe out more slowly still. The journey is over, the night is deep, and somewhere out in the quiet dark, a pale gold light continues to shine, asking nothing of you, promising nothing, just shining, the way it has always shone, the way it will always shine, long after this night has given way to morning, and morning has given way to another night and another and another, in a long slow chain of days and years that stretches out across the life of the universe, unbroken, unhurried, and at peace.